How's it going, everyone? Welcome. Eulio Gonzalez here. Let's go into now explore about what this conflict resolution looks like, and especially here on the Git. So the TLDR of this course is just to understand now how Git works behind the scenes. So anytime that we do, for example, some basic and some advanced commit, or when we want to solve, we're going to do some conflict resolution between two different state of the applications, whether it's our local chains versus the remote and vice versa. So when we need to use, for example, commands like git merge, git rebase, cherry picks, we know what's going on behind the scenes, and that's the entire reason of this video now, or this series of videos. So the TLDR of this, or in today's video, we're going to go to explore is working with remote repositories. So we're going to make a quick recap of how do we get here. So Git was invented by Linux Torvald because he can hold the entire system kernel Linux on his head. So we as mere mortals, we can now at least be somewhat close to him. So that's why he invented this particularly distributed version control system. So the benefit of this is that, as I mentioned before, we can now have a local copy of the entire project, all right? Add some change, and then when we want to synchronize with somebody, we can do that by now comparing their little remote changes and then do some conflict resolution, right? Which is something that we're gonna do later on. So we look at what this Git is all about, the data structure underneath, which is an acyclic graph, and some or the architecture of Git, which is the porcelain and the plumbing commands. So we're gonna focus on 14 plumbing commands, and then also going down deep into the root of some of these plumbing command. But the TLDR is to understand now what is the mechanism that Git allows us to, or how it operates behind the scenes, and some concept that we need to know. So for example, repo, which is the Git track project, and also the commit, which is it represents the state of the entire application at that moment when you do that, when you commit those changes, where you can now recreate the entire project of that. So it doesn't store any diff, as you might think what it does. It just stores the entire state of the entire application. You store all of the files and it changes in a memory efficient way. So also another concept like commits, right? So what is doing commit behind the scenes? So what is the different staging areas or the different places where now Git allocate to keep track your changes, your file changes on track, stage, and then on the track area. So the working tree directory, something that we're gonna see that later. And now what is going on when you now initialize a repo with Git, how you can have access to the configurations, and what are these configurations look like. And then once you initialize a repo, it creates a folder structure that allows to keep track of all of these state changes. When you now add some files with some changes, and then you move that to the staging area, from the on track to staging area, once you do the git add, and then you move that to the commit, which is something that you are sure that this will be the state of your app that you want to be, all right? Then what happens behind the scene is that now Git create now a node in this acyclic graph, all right, that contains the tree, which is the easy way to think about it is this is a folder structure that you can now look at that because it exposes you now a commit or a SHA, which is a 40 length character. So when you use now some low level commit or this plumbing commit like git cat file minus p, which is the flag, with the commit you can pass is the first seven numbers or alphanumeric string, and then you're going to tell you, hey, that commit for the tree node, that commit that stored the SHA, it also have a reference to the file. And this file now has a commit that has a reference or a SHA to the content of the file. So this is now the structure of how now Git actually keep track and store your application. This is quite revealing because once we look at this and how can we create branches and what a branch is, which is just a under the Git folder project is just a reference. So anytime you create now a branch which is virtually free, it under the ref create now is this SHA file with the name of the branch, and the content of the file is pointed to the commit you were when you create that branch, right? So back in that time, back in that moment, the commit that you made that, now this is the branch that is pointing to. So this is great. It's actually virtually free because it's only 40 length character plus the name of the branch. And then when it comes to actually now creating several different histories, or in any case is different state of the applications and how you can solve all of this, or branching, merging, and rebasing. So merging and rebasing are two techniques for conflict resolution from different history, and then you want to solve that. So merge, say, hey, let me take a look at these two different branch, all right? And then let me look at the best common ancestor. And from there, I'm going to replay all of this commit per different stories, and then create now a new merge commit with all of those changes that you want to. So another thing is that what happened when your branch, okay, in some cases, if your branch doesn't have any diverge, so the base merge commit or the best common ancestor of these two branch, actually they don't have any diversion, any different stories. They are like this. So when you do a merge, you can do a fast forward to this. And this is the best case scenario. And also another technique is rebasing, which the name itself say, hey, if you have two different branch, and then you want to try to make your Git history linear, all right? Because it is way much more easy to reverse changes or squash commits. So for some reason in productions, you have now push some wrong state, or you have some issue problems at production, you can easily migrate back. Okay, you can easily roll back all of your changes to these previous states, and then your app will behave as expected, right? So in those moments, right? So if you want to now, based on this diverse history, they have now this purge commit where they have the same common ancestor. And if you for some reason wants to move that to look like this, so you have now is a linear history, unlike a merge where you have now this and then all of this, right? So the more merge you do, it can be quite hard to read and to understand what's going on there, right? But with Rebase, you have now the ability to say, hey, what is the common ancestor of these two different stories? And then I'm going to reset the best, I'm going to reset the base commit of this branch, whatever branch you pick, all right, which is usually is the branch that you are currently at. Exactly. Let me actually remember that, because this kind of detail is quite important. Absolutely. Do, do, do. Wait, what? But I think it takes is the current base. Okay, so here, is something that needs to be done. Okay, no, it's okay, it's okay. Good, good, good. It's not there. No problem. You check. Okay. So a rebase reset the current branch commit. Okay, a rebase reset the current branch best common ancestor commit to point to the tip of the target branch. Create a temp branch. Create a temp branch of the current branch and replay all of those commits on top of the target branch. So for example, you say git rebase trunk, and then you are now, and say git is point, so git branch or git head is at, let's say, foo branch, right? So when you run git rebase trunk while your head is at the foo branch, git perform this step. Identify the common ancestor between your current branch foo and the target branch trunk. All right. Exactly. It temporarily saves all the commit in your current branch that come after the common ancestor. It moves the head of your current branch to the point to the tip of the target branch trunk. Exactly. Hey, I'm going to move the head to the tip of the target branch, and then replay each of your saved commit on top of this new bay one by one. This effectively make it look like you create your feature branch from the latest version of your trunk rather than from whatever you actually branch off early. The key benefit is that give you a cleaner, linear history, but this is exactly what it's doing. And this is important to make all of this detailed because the devil is in the detail. So yeah, this is what it does, merging and rebasing. So far, so good. Now, we also look at other things that are quite relevant. For example, like head. Head points to whatever is, wherever you are currently at. Wherever commit you are currently at. That's where head is pointing to. In reflog, actually keep track of where the head has been, and by using reflog, which is a predefined version of the logs that get stored of your head, okay, you can now bring from the dead all commits that you might have delete, for example, all branch that you delete, and by looking now at that ref log, you can actually is take that commit and then replace on top of your commit. This is something that is vastly used, and I see the potential and the benefit of doing that, because at the end of the day, this is exactly what it does. This is exactly perhaps what you need to do, right? So you have some old commit in some particular branch, and then you want to cherry pick that and place that on top of another different branch, right? That is quite interesting, powerful, and fantastic. Remember that you must have a clean history or a clean workspace before doing something like that. So we also look at working with remote repository. The TL is that git fetch, git pull, and git push. So git fetch or all of these commands allow you to not only is fetch the git history, the objects and the reference, not only get the git history from a remote computer or from your own local computer. Let's say you are now keep tracking is a different path. And that's also interesting. I didn't know about it. And the other is that you can now with git pull online git fetch, because it git fetch only fetch your remote objects or remote commits in reference, aka your branches, but it doesn't merge those with your local ones. That's when you use now git pull. And because you need to explicitly tell to git pull what will be is the branch that you want to fetch and then merge, you need to set that as the upstream. And there are two concepts here. You have now the upstream and the authoritative. So the upstream is when you now make a fork of a particular repo, and then you want to now submit that to the fork. And the authoritarian is when you want to actually submit to so your changes to the main repo that you did from where you branch off, or when you fork, from when you make your fork, from when you make your initial fork, right? So the TLDR of this is that you have a fork, so you have the authoritarian repo, and you create a fork, and if you want to now, for example, add some of your changes to this fork, you call this upstream. And if you want to actually merge those changes, then you call this as the authoritarian branch. When can we use rebase and merge? According to the prime engine, right? The prime engine is that for private repos, use rebase, and that makes a lot of sense because is altering the history of your branch, and if you do that for public branch, you're going to crash for everybody. So you're going to break it for everybody, and you are now in trouble. And for merge or for adding new changes to your public repo, use merge, right? So that was the TLDR of working with this. And now when it comes to conflict resolution, okay, we have now this staging. Let's get into this. Conflict resolution, all right? We have now the staging. Exactly, we have now the staging, stashing, all right, stashing, resolving conflict with merge, resolving conflict with rebase, all right, and rebasing practice. Potential problem with rebase, reuse recorded solution, ours and theirs, and interactive rebase. So here we're looking now is at how can we handle is these techniques. I don't think that yeah, let's get into this. Let's get into this.
We are at this point where you have a change you've made locally, and now you have a change you need to pull in from remote. What do you do? Typically, most people say stash it. You can technically commit and rebase, and then you have your commit on top, but you pulled in the changes that you need. And so you kind of you do have options here, but there is a third option, which we'll talk about later, which is work trees, which is my favorite way to do this. So, but for now, we're gonna actually start talking about stash. So for those that don't know anything about stash, stash takes every tracked change.
So, exactly. So now, so now you have your local changes, and the remote repo has their changes. Okay. So now you have your local changes, and the remote repo has their changes. And how do we deal with it? Right? So one way to do it is by pulling, exactly, by running git pull, all right, with Rebase. Okay, git pull with Rebase, where you say it's like, hey, give me all of the changes from that, all right, and then I want to move my local changes at the tip of that remote branch, or at the tip of those changes that I fetch from, all right, and then replace my own on top of that. Sounds great, right? Sounds great. Sounds great. Okay.
Change by git inside the index and the working tree, and stores them kind of into a special area, the work in progress area.
Mm-hmm. So, but for now, let's go. So let's go with stashing, right? That's what it is. We are now looking at stashing. But now we are able to see what's going on behind the scene. It's like, okay, that is so interesting. It's very interesting. Absolutely. Mm-hmm. All right, here we are. Okay, so this is git stash. We'll take every change track by git and change to index plus change to work tree and store that result, much like a commit into stash. To go from the main page, use git stash when you want to record the current state of the working directory and the index. So let's go to actually recap about the working tree, the working tree, or the main tree. This is your git repo, stuff that git will track in that folder. That actually doesn't tell me anything. Okay, but again, this is your git repo. Oh, so the work. Okay. Oh, okay. So wait a single moment. Wait a single moment. So if I ask to Claw and say, hey, uh, mhm, working tree is the Git folder. No, the working tree is not the Git folder. Let me clarify. Working tree, also called working directory. This is the actual directory on your file system containing all your project files that you can see and edit. It's where you make changes to your files. Mm-hmm. And repo? In Git refers to the entire project directory that is tracked by Git. It consists of two main parts. The working tree, okay. Mm-hmm. And the Git directory, the hidden directory that contains all the Git metadata, history, and internal tracking information. When you create a new repository with Git init or clone an existing one, Git clone, you are creating or downloading both the working tree and the Git directory. This is also important to understand that the working tree is the directory containing your project file and the Git directory that is now containing all of the Git history that also is storing, this is interesting, that is storing is in a memory efficient way the state of your application, so all of those files at that moment. Mm-hmm. So basically with Git you are now storing twice the working tree. One of them is the project, and the other are the file that is being tracked. That is being tracked of. Exactly. You're creating a snapshot of your file at that point in time and storing it efficiently in its database. It doesn't literally duplicate your entire project for each commit. This is why a Git repository with hundreds of commits doesn't take up hundreds of time the space of your project. The storage is highly optimized to minimize duplication. Okay. Okay. So, but this is the working tree. This is your Git repo. The stuff that Git will track in that folder. Okay. Alright. So the working directory. The stuff that Git will track of that directory. So you use git stash when you want to record the current state of the working directory and the index. When you want to record the current state of the working directory and the index, but want to go back to a clean working directory, this command saves you local modification away and reverse the history directory to match the head commit.
The stash area, and you can think of stash like a stack of temporary changes. This is from the man page. Using git stash when you record the current state of the working directory and the index, but want to go back to a clean working directory. The command saves your local modifications away and reverts the working directory to match head commit. All right, so pretty straightforward. Stash is a stack. I want to make sure I say that multiple times. It's just a stack of changes.
Stash is a stack of temporary changes.
So operation, you can push to your stack by your stash by executing git stash. You can even give a friendly message with -m. So this right here would stash, but with a message. Stashes can be listed out with git list or git stash list, and git show with an index as well. Show will just show the changes or the diff, whereas list will list out the amount of stashes you have. You can pop the latest stash with git stash pop. You can pop at an index with -- index. So if you want the third stash in, you can just -- index 3. Or I think it might be Rebase. I forgot. Pop. Show will just show the changes or the diff, whereas list will list out the amount of stashes you have. You can pop the latest stash with git stash pop. You can pop at an index with -- index. So if you want the third stash in, you can just -- index 3. Or I think it might be Rebase. I forget if it's 0 or 1. All right, so to create conflict, we're at this point where you have a change you've made locally, and now you have a change you can pull in from remote. What do you do? Typically, most people say stash it. You can even give a friendly message with -m. So this right here would stash, but with a message. Stashes can be listed out with get list or get stash list, and get show at with an index as well. Show will just show the changes or the diff, whereas list will list out the amount of stashes you have. You can pop the latest stash with get stash pop. You can pop at an index with -.
You can use also
so if you want the third stash in,
you have some steeply
just pop at an index with -index. Whereas list will list out the amount of stashes you have. You can pop the latest stash with get stash pop. You can pop at an index with -, or the diff, whereas list will list out the amount of stashes you have. You can pop the latest stash with get stash pop. You can pop at an index with -index, whereas list will list out the amount of stashes you have.
Show.
You can pop the latest stash with get stash pop. You can pop at an index with -index. So if you want the third stash in, you can just -index 3, or I think it might be 0.
Get stash pop to actually remove them. Get stash pop. You can also say get stash pop with an index. It's like, hey, we need to take this
zero base, and I forget if it's 0 or
this.
1 base. I assume everything's 0 base unless you're using Lua, so we'll just say -2 for the third option. All right, man get stash is your friend. If you forget how it works, again, use the friendly manual. Love the friendly manual. Read the friendly manual. That's what RTFM stands for, by the way. So if you ever see it on the internet, just remember it's the friendly manual. All right, so problem. We're gonna use trunk, and I want you to create an upstream change. Remember, this is gonna be in hello get. The internet, just remember it's the friendly manual. All right. And I want you to create an upstream change. Remember, this is going to be in hello get. Just create a file called upstream and put upstream change into it. Then in remote, I want you to do a downstream change in the README. Okay? So remember, these are 2 different files, and I want you to do it like this. So I will literally copy this. I'm going to go to hello get. Just execute that, get add this, get commit, upstream.
But you are not, you're running the hello get.
Then I'm going to do this one right here, so I just don't mess it up. Look at that. All right. There we go. So now remote has a change. Oh, dang it. Get check out trunk. There we go. Look at that. All right, there we go. Get this thing, and then add this thing, and then commit this thing. There we go. Okay. So make sure you do it to trunk, as I stated explicitly in the instructions, and would never accidentally deviate from said things. This thing, and then.
So you're wearing the bar.
And add this thing, and then commit this thing. There we go. Okay. So make sure you do it to trunk, as I stated explicitly in the instructions, and would never accidentally deviate from said things. All right. So now, I actually did deviate. I said don't commit, by the way, the second one. Don't commit the changes. Did anyone commit the changes in remote get? You committed it. Do git reset --soft head ~1. I'll do it too. Git reset soft head ~1. There we go. Now I have that lovely little change right here, and trunk is now pointing 1 step back.
Okay.
Beautiful. Okay, so I have my remote get set up, but now we got this call, production's down. There is a change you need to make, or there's a change you need to pull in from our upstream. So we're going to attempt to pull it in with an active change. So let's start there. So do a git pull with the right here, git pull. Wait a second, did I miss one thing? That it should say, hey, you don't do that. I think that's probably because I had rebase automatically on. So I think I actually had my little change in where I had rebase true. So I was causing a bit of you cannot pull with rebase. So oopsie daisies, right? And so since I have an active change, it's not letting me do those changes. So whenever you try to pull and you have active changes, it's going to tell you can't do this. So we need to be able to stash. So we'll just go like this. We'll do another one of those echo upstream change into here. Git add this, git commit, upstream change. There we go. We have the upstream change in hello. Now we go to the remote, and we can go echo downstream change into the README. So now we have something in the README, and we have a change we need to get from hello. So what are we going to do now? We are going to use stash, right? So this is what you do at this point. You'd want to stash any of your changes to prevent any errors from happening, and then you're going to want to be able to get the changes, and then you're going to want to be able to unstash, right? So this is typically what you're going to want to do. So right now, before we do anything, let's stash our changes. So you can experiment by going get stash, and then go get status. Your changes are gone, right? Don't pull yet. Don't pull. You can view your stash list. This is a good kind of activity to get into, viewing your stash list, because it's really nice to know that you can even do that. So again, get stash list. So if you ever get into this, you will know. So we have this work in progress that we've stored right here. At this point in time, you can see, okay, I was at this commit. Not very informative though, right? When you look at this, you don't really know what your stash changes are or anything. So we can go get stash show. A little bit nicer to see, oh, okay, this is the one where I made a change to readme. So a little bit nicer.
That I made.
Let's pop our stashes this time. And when we pop it, I want to see that it's now made that change. Get stash pop. There we go. Our change is back. It's right here.
Back here.
All right. Now let's stash our changes again, but this time let's use a custom message. So go get stash with a message. Readme changes. There we go. We did a stash again, but this time with a custom message. So now do get stash list. Now look at that. Isn't that a lot nicer to do? When you have a nice message, because the reality is sometimes you will have a couple stashes and you're not going to remember what's in these stashes. And so just having a nice little friendly message to yourself it'll just save a lot of headaches rather than trying to go through, get all the diffs and looking at each different one and then realizing, oh gosh, like there's the one I'm looking for. So now let's create another change and we'll stash that so we have 2 in the list. All right. So let's go another one. I'll just go vim readme and I don't know, just add another line. There we go. Dvorak, by the way. And then I'll go get stash another change. So now when I go get stash list, I'll actually see 2 changes. I have another change on top, and the readme changes on bottom. So the readme changes is the first set of changes we did. Another change is the second set of changes we did. But notice it's on top. It's the first one.
Because
so let's pull our upstream changes now. So I'm going to go get pull. There we go. I have this beautiful upstream change. Now, let's get our original change back, the first stash we did. Does anyone remember how you're going to get the first stash out? Not the second, not the one we just added, but the first one.
Get that
the
with the
there you go.
index.
So what you should be doing is going get
stash.
So first you can go get stash list. Make sure.
English.
Okay, I need to pull out the first one right here. I can go get
stash
pop index 1. And now we have that proper change. We don't have the Dvorak one, right? We have the downstream change. So working with stash, pretty easy to use. Now we have this beautiful change on top. Awesome. And if we want to, we can even commit it if we want to, but stage is not changed. There we go. And it looks like even in here, I commit it, so we will commit it with the exact same beautiful message that I have right here. Oopsies, that's copying from terminal. Get add. Greatest change. Fantastic. There we go.
Okay.
So commit that into your code. That means your readme should approximately look like that. I have a little space in here. It's not. There's no space in my example one.
Okay, so this is the remote git.
Because my first commit contained that. It's that one right there. See, look at that. I added a space, but in all my examples, I didn't have the space. Very painful for me to see this. I can't believe I did that. By the way, if you don't know, I don't cover it in this course, but -S will search like your commit message, or it'll search the commit change, so you can look for changes that way. Very, very fantastic. That's how I knew where to find it. That's how I found it right away. Pretty neat stuff, just in case you're wondering. All right, so work trees. We're going to talk about this in a little bit, I believe. I'm not sure. Yeah, we're not talking about it right now, but we're going to talk about it a little bit. The thing that makes work trees so cool is that a work tree is another copy of your repo without all the weight of a repo. So if it takes you 5 minutes to download to clone out a repo, you can build a work tree effectively just as fast as you can build a branch. They're very, very lightweight and they're fantastic. So you can see why that could be a very nice alternative to Stash. All right, so we're going to do more very, very lightweight.
So work tree, we'll talk about more of this, but generally this is my favorite way to work in fast evolving code bases.
And they're fantastic. So.
And the other is a work trees like this.
You can see why that could be a very nice alternative to Stash. All right, so we're going to do more rebasing. This will be the longest section here, and it's going to have all the conflicts and everything, and we're going to go over it. It's going to take a little bit. So anyways, rebasing, you can do things like this, where we start off here, right? E is branching off of A. This picture makes it look like it's branching off of B. I'm not sure which one I chose to have. Or rebasing.
This is more rebasing.
The longest section here, and it's going to have all the conflicts and everything, and we're going to go over it. It's going to take a little bit. So anyways, rebasing, you can do things like this, where we start off here, right? E is branching off of A. This picture makes it look like it's branching off of B. I'm not sure which one I chose to have it actually branch off of. It doesn't really matter. It branches off in the days of history way back then. And if you do a rebase, this picture makes it look like it's branching off of B. I'm not sure which one I chose to have it actually branch off of. It doesn't really matter. It branches off in the days of history way back then. And if you do a rebase, this picture makes, right? E is branching. It's gonna take a little bit. So anyways, rebasing, you can do things like this, where we start off here, right? E is branching off of A. This picture makes it look like it's branching off of B. I'm not sure which one I chose to have it actually branch off of. It doesn't really matter. It branches off in the days of history way back then. And if you do a rebase, you can make it so that.
And if you do into a rebase, you can make this to have now this linear.
That goes all the way to the front, right? We all remember this. What are the steps that happen? Step 1, we check out the branch we're rebasing on. Step 2, we play our commits one at a time at the tip of the branch we are rebasing.
So the thing here is that with rebase is that we check out to the branch that we want to rebase, right, which is the current branch. Then we want to rebase to the target branch that we want to. And what it's doing is creating now a local copy of our current branch. And then move the best common ancestors, and then move or reset the best common ancestor to now point to the tip of the target branch, right? And then going to replay each one of those independently. So allow you to now resolve all of those issues, or to resolve of those rebase conflicts. And that's one of the things that you have now interactive rebase.
Basing on. 3, we update the branch we were on with the new position and the new commit. That's why it alters histories, because remember, it's actually creating a new set of commits. Because remember, a commit also contains time.
This is also this is another reason why it's actually diverging or changing the history, because it's now playing all of this commit on top of this branch.
You get new commits.
So you are creating effectively a
everyone's good. Everyone's good on that one. Awesome.
Okay.
So first, let's do a little bit of interactive rebasing and squashing. So this part is where you'll do this pretty much on your own branches, never on the public one. Interactive rebasing and squashing allows you to take, say, this branch right here and turn it into this, where it's a single own branches.
Interactive rebasing and squashing. And this is quite interesting. Okay, more rebasing, something like this, right? So you take now is this one, all right, and then the other is this one, right? No. All right. More rebase. In other words, you make your history linear. Just simple visualization, assuming everything went off with a hitch, and you have the following state, right? That's when you do a more rebase. And when you want to do a interactive rebasing and squashing. So interactive rebasing and squashing, interactive rebasing and squashing. I think there is a missing S here. Right, exactly, you got it. Interactive rebasing and squashing.
Public one. Interactive rebasing and
It takes this, bro. It takes this, bro. You say it's now this. All right. Hopefully it's supposed to update it. No. That's quite interesting. Okay. And then you want to
squashing
now
allows you to take, say, this branch right here and turn it into this branch right here and
turning into this. And turning into this. Okay.
Turn it into this, where it's a singular commit as opposed to 3 commits. So that means while you're working, you can make all the commits you want, every single checkpoint, And then when you're done, you can take all those commits and turn it into one commit yourself. Now, a lot of people do it where they have the remote, like say GitHub, will do an automatic squash merge for you. It'll first take all of your commits, squash it into one, and then merge it onto GitHub. That's a pretty common strategy that I've seen.
This is a very common strategy, especially when you do a PR. When you want to merge all of your changes, despite the changes that might not be in the perfect state, but as long as you now are sure that that PR actually fix on issues or add new bug fix, whatever gender, whatever it is, but at least you know that that PR actually do what it's supposed to do, all right? Then you can say, all right, now it makes a lot of sense to now squash all of those into one single commit, which contains is the feature or the bug fix that you want to then merge into your public branch
at Netflix. So I think most people probably have some very similar experience. When you do interactive rebasing, it also allows you to edit the message. So that way, like what I typically do is I'll do each one of my commits and I'll start with squash me. So I can just look in the history and go, okay, where did I start? Okay, I started right here, rebase from right there. And then it's very easy. Then I interactive and then I can just erase all the messages and give it a nice proper message as opposed to a bunch of squash me's, right? And so we're gonna create some situations where we can interactively squash our commits and get some good messaging. There's a lot of ground to cover here. We're gonna go over conflicts, because conflicts are a very important part of this. If for whatever reason I've done steps out of order and we're unable to create the conflict as easily, we might have to add some extra commits because that's part of the fun, is that we didn't do it right the first try. So be very careful where we make changes, because from here on out we're gonna be trying to make conflicts and we all want to be on the same page. So the first, by the way, conflicts are the most dreaded topic. I hate them. I don't know why. I have an unreasonable amount of anxiety every time I poll, going, man, there's gonna be a conflict. And even though I know there's not, I still just feel like I'm gonna have a freak out. I don't know why it is. It just is that experience. Yeah, I hate them, you hate them, but it's good to know how to resolve them. Please, by the way, don't use VS Code, don't use Fugitive with Git or with Vim, don't use any of those for this. Let's just manually edit the diffs. You want to see why they're doing this. It's gonna be very important, especially with your knowledge of Rebase, why conflicts can be goofy with Rebase versus merge. We're gonna go through it all, but if you're not using the hand edit, you're just using a program, you may miss some of these subtle.
Okay, goofy, that word, goofy, bro, goofy. Urban, goofy. Drug dealer slang. What the hell is the Urban Dictionary? A goofy is a silly ass motherfucker who kind wacky, but they chill. You're a fucking goofy, bro. And the other is drug dealers. Is a silly ass motherfucker who kind wacky. A word that means crazy and it weird, different from others, silly or funny. You are so whack. You're so whack. Not a wacky website. Have you heard of that wacky website? You're so wacky. Wacky, bro. You're a fucking goofy, bro. But it's like exactly who is kind of wacky, but they chill. It's like one of kind of different, silly, but they chill. Kind of goofy. Masturbating with your non-dominant hand. What the? Being under the influence of marijuana. Being under the influence of marijuana. Goofy, gay or homosexual. What? Goofy, Chicago term for a lame or a snitch. Oh, you gotta be careful, man. You're a goofy. A lame or a snitch. Hey, bro, that goofy ass nigga snitching us. Goofy, someone who's dumb. Say anything dumb or does anything in a dumb, stupid manner. In Chicago term, a lame or snitch. Funny, cute gets annoying most of the time. Goofy. Wacky or goofy. Interesting. Okay, move on.
Full changes.
Move on. Move on.
All right, so to create a conflict, the easiest way to do that is you just have to make 2 changes that cannot be reconciled. In other words, just change the same line to 2 different things. So the problem, let's create a conflict in both remote and hello. To do this, we need to create a commit in both of them. And so we're gonna use trunk for both repos. We're gonna do an A+1 to hello and an A+2 to remote. And this will be in the README. So they both have A at the first line. So we'll create the same change in both. Let me just make sure that I don't do anything. Okay, good. So let's do that now. So I'm gonna first start off in hello. I'm gonna go to the README. I'm gonna add a +1, save that, add this, git commit, and then I'll do A+1, so I can just see the log. You know, I have the same message, so we kind of know what we're working with. And then I'll jump over here to remote and do the exact same thing, right? We're going here, A+2, save that, git add this, git commit, 2.
Okay.
There we go. We have now created the situation in which we are going to conflict. And now we just need to simply pull hello git onto remote, and it should cause the conflict. So git pull, there we go. We now have the official conflict. It's hurting us. We just need to simply pull
hello git into remote.
Hello git onto remote,
and
it should cause the conflict. So git pull, there we go.
So
we now have the official conflict. It's hurting us emotionally, but it's fantastic.
Okay.
So what is a conflict? It may not be obvious what is in the conflict, because often whenever you pull in changes, it's not just one file that's changed. Well, it's unlikely that it's one file that's changed. Usually you pull in a whole bunch of commits from other people, and you get a big list of things that are that have been changed, and you have like one file in there that's conflicting. And so using just this message right here to find which one, kind of a pain to do, right? That's why get status is a little bit easier, because you'll get something like this, both modified. And you can see that means it does not know how to resolve it. It can just tell you, hey, both
because with git pull,
the one you're on and the one you're pulling into have a change here, and we don't know how to resolve it. Oh yeah, by the way, you could always abort these type of things by doing a git merge abort or a git rebase abort, just so you know. And technically a git revert abort, git cherry pick abort, any of them that you have that availableness. I think with stash you can't abort that one. If I'm not mistaken, there's some other technique you're gonna have to do there. I can't remember with stash, but I'm pretty sure you can with stash. All right, so to resolve a conflict, let's open up the README and let's look at what's inside of it. So here it is for convenience, but for me, I like to look at things with Vim. Notice that we have head, a bunch of arrows, the change we made in remote, a bunch of equal signs, the change that's up on hello git, and then of course this with some sort of SHA, 7B00. If I jump over to hello and go git log 1, you'll see 7B00. It's this commit. It's letting you know which commit you're currently resolving against. So when I go here, what this says to me, or what it's trying to convey to you, is that from this place to the equal sign is your change, and from the equal sign to this is this commit's change. And so now you need to pick which one you want. Technically, I could delete this, and this, and have them both if I really wanted to, or I could just have hello, or I could just have remote, right? You get to choose how you want to resolve it. That's why if you've ever noticed whenever you're using those, like some sort of visual program, you will get to select one side or the other, and then you have like in the middle the ability to edit it. It's because often a conflict isn't as simple as choosing one side or the other. It's you kind of have to like mash them together and make sure things work.
Okay.
Anyways, spend all that. All right. So validate your SHA. We already validated the SHA. All right. So we are conflicted and we want to resolve it. Use the status message to identify which one. We already did that. And let's choose our remote git change. Okay. So that means you want to keep the one with between head and the equal sign, or A+2. So we're gonna keep
head
remote
and
git
the equal
change.
signs.
So this is the final state we should be into. Make sure my notes actually agree with me. Yeah. Okay. Whew. Right? Make sure you pretty much end the file looking like this. I'm not going to delete the line that I have right here because I just don't want to play with history at all. I want everything to keep on going there, but normally I feel the need to delete it. And just in case you all feel the same need that I need, just letting you know why I'm not deleting it. All right, so there we go. We have resolved the conflict. And if I go get status, it still says the same thing. We need to resolve this conflict still, right? Even though I've deleted all the conflicting lines, Git has not moved forward. It doesn't just move forward automatically when none of those lines are left. It waits for you to tell it, I'm ready for you to move forward.
For you, which is git
so
add.
Let's commit the merge now. So all we have to do is do a little quick git add, and then we get to commit it with whatever message we want, right? So I'll just say, merged in upstream. There we go. We've merged in upstream. We've resolved the conflict. We had to do it manually, had to choose whatever side we wanted, and we happen to choose our remote side, not a hello side. Fantastic. Just absolutely just so happy. Jeez. All right. Oh, I forgot to put the status. Oh, that's so sad. If you execute status, so one thing here, we'll look at it right here. If I were to do status before I committed the change, when I added the README went away. Why is that? It's not on the status anymore.
On branch trunks, all conflict fixes But you're still merging. Use git commit to conclude merge.
It's quite simple. There's no change. Right? We kept our change from remote.
But this is once you've
got it right here.
This is once
if I were to do
fixed
status
that.
before I committed the change, when I forgot to put the status. Oh, that's so sad. If you execute status, so one thing here, we'll look at it right here. If I were to do status before I committed the change, when I added the README went away. Why is that? It's not on the status anymore. It's quite simple.
Change.
There's no change, right? We kept our change from remote. Therefore, by resolving this conflict, we're still in a state that needs to be committed. We just haven't. We just have no change. It's just an empty commit, right? There's nothing there. It's kind of a little fun fact. Anyways, we can use git log to kind of look into it. So if you go like this, git log, you'll see, okay, we see the merge upstream. We actually see our origin, where our origin trunk is currently pointing to. We see our change. If we do git, this is where graph gets really cool. If you do it with graph, you can actually see, okay, now I can see that this happened. I can see this is a merge commit with 2 parents. You can see which parents are which. There's our upstream one.
Commits.
Here's our last commit down here. So you can kind of look at them. I also think it's kind of neat that there's 2 zeros right here and 2 zeros right here and 2 zeros right here. Feels weird to me. I love those kind of things. I don't know why. I just find it very entertaining when SHAs are close to each other. I don't know, kind of weird guy, but all right. So 2 conflicts are better than 1, right? I agree, but we're not going to do this quite yet. So what I want you to do is I want you to make a change to bar, and I want you to pull in the change into the remote. Like that's it. Very, very simple change.
So when I
That's
make
it.
a change
I'm just
to
going to
the bar,
copy this one, a no conflict change to bar.
and hello git.
So I'm going to go back to
Okay,
hello,
you go hello git.
change bar, git add this,
bar,
git commit,
git commit this.
a change to bar. Very, very simple, right? We're going to do that, remember, in our upstream, in hello. For those that are wondering what I'm doing right here, this little maneuver here, when you do echo anything, you are echoing it out to the standard out. And all kind of programs running, there's a standard in, there's a standard out. I can redirect any output to a file. 2 things mean that I not only redirect it to a file, but I append it to the end. So just in case you forgot about that, it's just when you're doing these little exercises, it makes things really, really easy to just do this, because I don't need to open the file and then edit it and then close the file and save and go through all of it. I'll just put the standard out right into the file. So now let's pull in the change into the remote. So I'm going to jump over here and go git pull.
Git pull. And look at that.
Look at that.
We have now a different. What will happen is that, hey, this input saying, hey, we have now 2 different branch. So the hello trunk, the hello here, which is something that we exactly.
So now let's pull in the change into the remote.
So here, if you go to remote here, exactly, it's because you have now a different branch. So you have now a diversion. So you have different history here.
Pull.
You say, hey, you have different history here.
Look at that. We have diverging histories, right?
Exactly. Completely.
Right?
Exactly.
Yeah, because I have my change that
you have my changes. We have now a base merge commit with this branch or this line, and then the remote have now some diverged history. Right?
I made a merge commit that I merged in. There was a conflict. I changed that conflict. I never told hello git or the upstream about this conflict. I never pushed any change for it. So now, every time I make a change, I have to do a merge commit because we have different histories. So this is where things can quickly get a lot of extra commits in life, because now we just have even more. You know, like every time I pull in a change now, like if I pull in 1 change at a time, I will get 2 commits per pull. So this is where the thing starts to get kind of annoying with merge. Even though some people really like it, I'm just not a big fan of it. There we go. So this will keep on going over and over again, by the way. So if we look at our graph, by the way, our graph looks so good. 1 line graph, just so sweet. Look at that little trapezoidal type figure going on right there. But you can see that every time it does that, we're just going to have to keep on doing these little merge configs. Also, it's like Google colors. Strange. Okay. All right, takeaways. Once you resolve a conflict and you don't merge it back up, you're going to have problems over and over again. Anytime you're diverging in history, you're just going to have merge conflicts or merge commits every single time you pull. So keep yourself in sync as much as possible. It avoids these.
Yeah.
Let's do a conflict, but this time let's do it with Rebase. Because remember, Rebase is fundamentally different than merge. Merge finds the best common ancestor, replays those things, creates a merge commit, and that's that. Whereas Rebase will actually move your changes forward to the tip, and then replay a change at a time, which means that different things can happen during a conflict.
On top of that, remote
Again,
changes.
I want to make sure everybody remembers. With
Rebase,
Rebase,
now is you have different
moves
history.
everything forward, plays the commits 1 at a time. Very important. Very important, which means it also checks out the target branch, or the source branch, then replays it. very important to remember that because it's going to kind of see how this works. All right, so now here's another interesting thing. Let's pretend that C and G had a conflict. We had to resolve it. What happened if we get another change upstream and then we rebase again? Are we going to get another conflict?
No. You want
Why
to
should we or why
rebase?
should we not?
No, I want to rebase that.
He still had the conflicting change. It's still going to conflict.
Yeah, because remember, we take our commits, we then check out the branch we're trying to rebase on, we go to the end, then we replay our commits one at a time. Which means if we replay a commit that conflicts, it will conflict again and again and again and again. Now there is a resolution around this. It's in fact, it's such an unheard of option that you can even use it in a sentence to somebody's face and they won't even know you are telling them the solution because of how fun it is. All right. It's just the best. It's just the best. All right, so let's do this again. It's fun. We're masochists. We're computer scientists. We got to make sure that we experience this over and over again. So the first thing we want to do is let's make sure we first have no more merge commits, any more of that. So let's get our branch in sync with hello. So I'm going to push from remote to hello right now. We don't want any more merge commits. So push, get push. Does anyone know what happened here?
So,
With
okay.
hello. So I'm going to push from.
So you want to ensure everything continues ongoing smooth. Let's update trunk in get hello get. Okay. With push from hello get. What?
From remote to hello right now. We don't want any more merge commits. So
So here in the remote we say
Push,
get
get-
push.
push.
You say get push. Refusing to update checkout branch ref trunk. By default, updating the current branch is a non-bare repository. It is denied because it will make the index on work tree inconsistent with what you push and will require git reset hard to match the work tree to head. So you can set the receive.deny current branch configuration values, okay, to ignore or warn in the remote repository to allow pushing into its current branch. However, this will not recommended unless you arrange to update its work tree to match what you push in some other ways. To squeal this method and still keep the default behavior, set the default deny current branch to this. It's like, hey, I couldn't branch is currently checked out. Failed to push some of the ref to hello get. Okay, the reference is to there. I couldn't now upload or push those changes here. Okay, refusing to update checkout branch ref heads trunk. By default, updating the current branch is a non-bare repository. Updating the current branch here is denied because it will make the index and work tree inconsistent. So it's denied because it will make the work tree and index inconsistent with what you have pushed and will require git reset hard to match the work tree to the head.
Does anyone know what happened here? You probably got the same error if you've been paying attention.
So it's trying to push some changes in a different branch on the remote, right? And it's not allowing you to do because you will have now a different working tree.
Read the error message. Read the friendly manual, as they say. Read the friendly error. I'm trying to push to trunk. What am I currently checked out on in hello get? Trunk. Do you think it'd be good if you were programming and someone could push to your branch in such a way that would change it out of underneath you? What could possibly go wrong? We're doing it live. This is like hot reloading, but of your entire code base. So instead, you probably want to go get checkout bar, go back, then push it, which works perfectly fine. Then you can get checkout trunk. There you go. Now, think about that. GitHub has to do the same thing, right? They can't have trunk checked out in whatever way they're managing your repo up there. It would have the exact same problem. It's kind of like a fun little GitHub checkout bar a way that would change it out of underneath you. What could possibly go wrong? We're doing it live. This is like hot reloading, but of your entire code base. So instead, you probably want to go get checkout bar, go back, then push it, which works perfectly fine. Then you can get checkout trunk. There you go. Now, think about that. GitHub has to do the same thing, right? They can't have trunk checked out in whatever way they're managing your repo up there. It would have the exact same problem. It's kind of like a fun little, don't do that type thing. Anyways, it's just a problem you pretty much never run into because normally you don't have two of the exact same repos on your machine that you're pushing to. Fun little experience right there. All right, awesome. I just wanted to go over that just because it's fun. If you looked at it, you'd see this remote rejected. It's currently checked out. It tells you right there in the air. Just kind of hard to see. All right, so we did all that. We changed branches. Fantastic. All right, so let's create another conflict via rebase instead of merge. So I added some bolds here just so I don't goof it up because I kept goofing it up when I do it by myself. So first, we need to create a change in hello get. We're going to go from a+2 to a+3. All right, so we're going to start in hello get. I'm going to go to the readme, and I'm going to go a+3. Fantastic. Then we're going to create another change in bar.md, the last line. Okay, we're going to go to the last line. So bar.md, go all the way down and go last line from hello. This is probably not what I put in the course, but you can follow along. Then I'm going to go get status. You can see those two changes. I could go get diff to look at the two changes if I wanted to. Okay, good. a+3, exactly. Add it to the last line. Fantastic. Git add this. Git commit. Let's go. I don't know what to call this thing. A change from hello get for rebase conflict. Enjoy your day. Very nice message. No, it's making me happy when I read it on the other side. All right, so now we're going to do the exact same thing in remote. I'm going to change a+2 to a+4. So and I'm going to make a change in bar, but this time to the first line, not the last line, the first line. This is important. All right, so we'll do it again. We'll increment that twice. Go to bar. We'll go first line, change bar. All right, we can see it right there. We can diff it if you want to. a+4, first line, awesome. Add in here, git commit, and then we'll go, change from remote for a wonderful rebase conflict. Awesome. Just makes me feel so happy doing it that way. All right, so now that we've done that, we're going to rebase remote git trunk with hello get and create the conflict. Now remember, that means you got to go git pull rebase.
Rebase, exactly. So git pull rebase from the remote git to hello get.
As long as you don't have the option auto magically enabled, this should just work now.
Exactly, because we already have that and automatically enabled that. So git pull rebase on that, and then what we're trying to do is with this trunk, trying to point to the tip of the remote branch hello trunk, all right, and then replay all of those changes on top of that. And it say, hey, auto merging conflict content, merge conflict in readme, and auto merging bar.md. Error could not apply could not apply this particular commit change from remote for a wonderful rebase conflict. Resolve conflict manually, mark then as resolved with git.add, and then run git rebase continue. You can instead skip this commit by run git rebase skip to abort this, but it says, hey, you could not apply A1C3 change from remote for a wonderful rebase conflict. It tells me that auto merging readme conflict content, merge conflict in readme, and not only for the readme but also for the bar.
There we go. We have this wonderful error message, but look at it kind of closely. What do you see here? I see, okay, getting some information from hello get. We're going to auto merge readme. Ooh, there's a conflict in readme. We're going to auto merge bar. No problems. Bar was nicely merged. The readme could not be merged. Therefore, we have to manually do this. All right, so let's check out the conflict. So if I go get status, you'll see right here that bar is in the green because it's ready. It's ready to be committed. It was able to merge it. Nothing you need to worry about. Like, you're good to go. But this one has the both modified. So this is what I was talking about with the whole both modified thing where you need to resolve it. And so we just simply have to go through and do the exact same thing. So let's fix the readme. All right? So I'm going to go vim readme. Now I want you to tell me something that's different than what it was with merge. What do you see?
So here you have this is your local changes. This is, okay, head points to the local changes. And anything that is below that is pointed to the remote changes.
That's different. How about this one? I'll go back here. I'll go like this. Readme. All right? So I'm going to go vim readme. I want you to tell me something that's different than what it was with merge. What do you see that's different? How about this one? I'll go back here. I'll go like this. Cat readme. A+3. Right?
So this is my current changes on the head.
Why does it say head is A+3?
Oh, Oh, because it's pointing to my local change on the top of that.
That's upstreams. That's not our change. That's upstream's change. Why is it head? Why does it say merge? What do you see that's different? How about this one? I'll go back here. I'll go like this, cat read me. So I'm gonna go modified thing where you need. And I want you to tell me something that's different than what it was with merge. What do you see that's different? How about this one? I'll go back here. I'll go like this, cat read me.
Hello git, exactly. Hello git.
A+3, right? Why does it say head is A+3? That's upstreams. That's not our change. That's upstream's change. Why is it head?
Because we're doing a pull rebase, and there is now updating the head to the tip of the remote branch.
That's where it currently is in the.
In Rebase, when you rebase, you check out the branch you're rebasing on, then you play your commits one at a time, then you check out the branch from whence you came, and then it's updated and nice, right? So you gotta remember that. So it's inverted when you're looking at Rebase. Ours is theirs and theirs is ours. It's that easy. By the way, this is like that. This is the one part of Git that's just like, it's, if you know how Rebase works, it makes perfect sense. And even when it makes perfect sense, it's still stupid, is how I feel about it. Like, I'm just like, why you gotta be like that? You know what I mean? You gotta reverse it. And the worst part is that once you remember this, and you go like this, okay, Rebase is the opposite one. You're gonna be like, dang it, is merge theirs and ours, or is it ours? And then which one's Rebase? And then all of a sudden you like reverse Uno yourself, and you're just like, dang it, I can't remember. So I'll just remember how Rebase works instead of trying to remember some cute way to remember that it's ours and theirs. If you just remember that Rebase first checks out the branch you're rebasing and then plays on top, it's very easy to always remember it. So just kind of like a little. That's 4 years of me being confused about theirs versus ours, and then finally just reading it. And then you don't reverse Uno yourself anymore. Let's see, let's choose our conflict in this case. Let's choose hello git's change. So remember, because we're currently checked out with hello git, so I'm just saying it from git's perspective. Let's check out, let's commit with hello git. Let's not commit with remote. So we'll go like this. We'll erase that, and that. There we go, A+3. I want the A+3 one. Now, don't goof this one up on accident, okay? You'll notice right here that it says, to be able to fix these conflicts, you do git rebase continue. If you accidentally do commit, you've seen me do it a couple times, which I haven't explained it yet, you can git reset soft, hit head tilde1, and you can undo your commit, and then rebase continue. Well, I'll show you that in a little bit, but there you go. So now I can go git add. There we go. Now notice that it went away. Why did it go away? Silence.
Because there's
Is that
no
the reason?
changes.
Just a strong silent type? No.
There's no changes.
Yes, it's because remember, right now, we're in perspective of hello git. We're in perspective of our upstream. Therefore, we accepted upstream's change. Therefore, there's no change right now. I know it's very frustrating to think about these things, but it's good kind of exercise to go through. Now you kind of know it, and it's like, oh, okay. I know, it's very easy to goof up. So now I just simply go git rebase continue. Now we get this opportunity to edit the message to say, hey, a wonderful, nice rebase conflict. I'm gonna save it, and there we go. It's beautiful. Where our branch is currently ahead of origin trunk by 1 commit. Awesome. If we do a little log 1 line.
Exactly.
I'm gonna save it. Continue.
And it says change from remote from wonderful rebase conflict. Please enter the commit message for your changes. Line starting with hash will be ignored. It's an interactive rebase in progress with this. Last command down and change to be modified or change to be committed with bar MD.
Now we get this opportunity to edit the message to say, hey, a wonderful, nice rebase conflict. I'm gonna save it, and there we go. It's beautiful.
But then when you save those changes by pushing, because what you did here is to you pull those changes from that. All right.
Where our branch is currently ahead of origin trunk by 1 commit. Awesome. If we do a little log 1 line, you can see right here, we had this wonderful change from hello git. Then we resolved the conflict, but there's no conflict commit, right? We just simply resolved it and continued our rebase, which means if I were to add in a-p, you could see we have the first line changed to bar, and that's it. We don't have the A+4 anymore. We literally erased it out of existence. I know, it's a little emotionally painful when you think about it. So this is some of the dangers of Rebase, is that you can actually, you're fully removing something right now. Because you moved forward your commit, then you edited your commit in such a way that you removed your change. Your change did not exist anymore, and now it's just this change you had left.
It's like somewhere in the ref log still, right?
That change? We could probably find it in the ref log for sure. So if you did like a git ref log,
Yeah,
where it is, This one right here is my guess. This looks about right. A change from remote and wonderful Rebase. So if I go like this, get log p this. Yeah, there it is. So you can see it right there still. Like we can get back to it. It's just since there was no conflict commit, you lose that information. So this would be like a good argument for why you shouldn't use Rebase. This is probably the best argument, honestly. I just don't think you get any better than this one. Just because I don't like the idea of losing information, but at the exact same time, it makes perfect sense if you erase your code. We're gonna do it again, except for this time, instead of accepting ours, which is theirs, we're gonna accept theirs, which is ours. Yeah? Yeah. So, in hello get, let's do a plus 5. In remote get, let's do a plus 6. So, let's go to our upstream, hello get, and go and do a plus 5. A plus 5. Perfect. I'm going to go to remote, and I'm going to go in here and go a plus 6. Okay, there we go. Get status, awesome. Get add this, get commit, a plus 6. There we go. Now we need to pull in our origin trunk and rebase on it. So get
So we're gonna get pull rebase. Okay, so ours are theirs, and theirs are ours. So ours are theirs, and theirs are ours. All right. So our change when we do this rebase is just will be like that. So ours are theirs. We point updating that, and then we're gonna replace. And we're gonna replay all of this commit on top of that remote branch.
rebase. Again, we have the simple conflict. We just need to resolve it now. And then remember, we're going to choose theirs, which is ours. We don't want to choose ours,
And so we're gonna choose their, which is ours.
which is theirs. So if you open up the README, you'll see there's a plus
So we're gonna choose is theirs, which is a plus 5.
6, which is in the theirs category. So erase that, save it. There we go. We've now officially done that. We go to status, we add it. If you check, which is in the theirs category.
Okay, theirs. Mine's and theirs. Exactly, because this is what it has, theirs.
So erase that, save it. There we go. We've now officially done that. We go to status, we add it. If you check in status, you can see right here all conflicts are fixed. Run this. It's waiting for you to say that you're done. I'm going to take this command, rebase continue.
Rebase continue. And now it's show you this message. We say, hey, we updating is the pointer to the tip of that branch, and they're going to replace all of this commit on top of that.
Awesome. Now we have a chance to edit our commit message if we want to. I'm going to keep it as a plus 6. Awesome. So I can go get log, one
So
line.
you don't
And
have
you can
now
see right
this
here.
merge commit.
There's that. Here's our previous change, and now we have the a plus 6 change. All right. This is where it just gets it just gets kind of annoying. We're gonna do this a little bit. Let's just add a new line right below a plus 6 and hello get. Just one new line, okay? So let's go to hello get, open up the README, and go new line. I'm gonna save it. Get status, get add, get commit, new line. Go back to remote, and I'm gonna get pull this one in with a rebase. Now remember,
If I do this, right? Okay. So head is ours and points is theirs.
rebase checks out the thing I'm going to, replace the commits one at a time.
So it's going to check out my local branch to the point to the tip of them. All right.
And look at this.
And they're going to replace on top of that, right? Because they say, hey, we're going to replace all that. There's some conflicts on top of this with the merge. Exactly.
Got a conflict. Don't fix the conflict. Just check it out.
Exactly. So which is our local changes and their changes x6.
Look at that. It's like we're all over again. We're doing the exact same thing again. We've already fixed it, yet here's the exact same conflict again.
This is their changes. When you do a rebase, this is their changes, and this is our local changes.
Again. So it can become a little bit emotionally painful if you have to fix the same conflict over and over and over again. It's almost like I wish Git you could reuse recorded resolutions. You know, like that'd be really, really nice, right? That's me saying to your face the thing you're supposed to use, and you don't realize that I'm saying it if you don't know about it. Yeah, you know, it's like the joke. You get it? It's like right there. It's pretty funny, huh? All right, anyway, so we see this. It's like, oh, man, this stinks, right? And so we could fix the conflict. Don't actually commit it. Let's fix the conflict to the point where we have a plus 6 plus the new line, right? So I'm going to have to merge those changes together, right? So I'm going to have to go delete that, delete this, and then move that one down. Kind of stinks, right? This is where things really get crappy when you have conflicts like that, because then they get really hard to understand. All right, so we're not going to resolve yet. By the way, does this make sense now with how Rebase works? Do we all understand why this happened? The replaying of commits, where we're going to conflict ad infinitum, because we're just replaying something that has changed in the same place twice. Remember, it always replays one at a time. All right, so we have an active conflict right now, and we need to resolve it. So given what you know, even though I've already foreshadowed and already told you, would you use Rebase if this was the experience of Rebase? My guess is most people probably really wouldn't want to necessarily use Rebase if it means you're going to conflict for any long-held branch over and over again. Like, that'd be a pretty bad experience, just in general. So, hey, that'd probably help you not have long-running feature branches, huh? So it's like a cure through pain and misery. So it's like, it's a really nice way to kind of fix that problem. But here we are. So anyways, I wouldn't personally want to use it just because it'd just be a pain. So instead, there's likely something you don't know about. It's called re. It's one of the strangest options in all of Git. It stands for reuse recorded resolutions. And even from the Git docs, it says this functionality is a bit of a hidden feature. It's like the best feature and it's hidden. Like, why would you do this? Like, why would you name it this? Why is it like this? It just is so painful that this. Why are you the way you are, right? Like, that's the meme, right? It's happening right before our eyes. And so all you have to do is enable re. You can enable it in your config, which means we can enable it locally just for this repo, or you can enable it globally for all of your repos. So for the sake of you not having your system altered in any sort of way, just enable it locally for just this repo. So I'm gonna go git config, add re, enabled with the D, right? Yeah, with the D, to true. There we go. We just did it. We enabled it. It's fantastic, right? And right now we're still conflicting. Remember that. We're still in the middle of this. It's terrible. Let's see where we're at. Okay, good. Everything, we have the change in there. So I'll just add it. We'll do a git rebase continue. It will play it. Whoopsies. I spelled continue wrong. We'll now edit our commit message. I'll keep the commit message the same because, again, remember, Rebase gives you the chance to edit your commit message. I don't want to edit it. Awesome. We've resolved the conflict.
Rebase gives you the ability to read your changes and then add it.
See something here. Okay, fantastic. We did this. By the way, it's on the local list, so if you do that, if you go git config, I forgot to say this, list local only, so these are only local options, you'll see re is right here. All right, you can cat out the git config. You see it right there. So, okay, awesome. It's been enabled. We're ready. Fantastic. And we already talked about what it is. It's not all sunshine and rainbows, by the way. Sometimes you could resolve something in a way you don't like, and you need to be able to go through, and you can actually delete how you have recorded your resolutions so they don't replay again. So that can kind of be a pain when you're like, oh, that was a bad merge. And then you try to pull again, and then it just automatically does it for you. And you're like, dang it, it just knew what I was doing, right? And you don't want that to happen, but it did. So just remember that. All right, so let's resolve our conflict and accept our change with a plus 6. So let's go back to hello git, and let's make a simple change to just upstream.md. Now, if we didn't have recorded resolutions on, we would actually conflict again here. But instead, if I go upstream, go right here, and go another change with a re, we'll go like that. We'll get add, we'll get commit, re, right? And now I can git pull rebase on remote, and it's just going to successfully rebase for us. Everything's great. We're not reconflicting. It's just smooth sailing now. So very nice. Very nice to have re on. I would highly recommend having it on. Just that only one thing you got to be careful about is, of course, the bad resolution. All right. Re is free. You can just use it for free. Nothing. So we're going to talk about ours and theirs. You've heard me say this multiple times now. Ours is theirs and theirs and ours with Rebase, whereas it's the opposite for merge. So long as you have one of those correct, you'll get the other one correct, or you can just remember how Rebase works. So sometimes you just want to be able to pick just one side. You don't want to have to go through and manually resolve each one of the things. You just want to say, hey, file or change A is better than change B. I just want change A, right? By the way, there's a very well-known Netflix person named Some Coding Guy, and he even says that ours and theirs is like the worst thing in Git. So it confuses everybody. So if you feel kind of confused about it, don't worry. You're not the only one that thinks it's completely ridiculous and also makes perfect sense, but ridiculous. All right. So when I say ours, I do mean our current branch. When I say theirs, I do mean the incoming branch. So if you want to select a change, you can just simply do get checkout -- hours path to the file, and it will just select the entire file's change set. And if you do theirs, it will select the entire file change set for just theirs, and it's only for that file. So let's do it again. Let's make another conflict. We'll do a+7 in hello, a+8 in remote, and let's do a merge from upstream to resolve it, and let's choose ours with a merge. So I'll go to hello,
So you go to hello,
in the README,
add the readme,
a+7,
a+7, commit those changes,
a+7, do it again here,
again. Now a+8, get commit with a+8.
there we go, I've got them both to hello and to remote. Now all I need to do is just simply merge those two together, and then we'll get the conflict, so get pull.
So get
Notice that I'm
pull.
using a merge, I'm not rebasing. Awesome, I have the conflict. Now I'm just gonna simply go get check out hours, readme. So if I do that and I go get status, you'll see it's still both, it says both modified because we haven't added it yet. If I cat the readme, you'll see it's just our change. It did it for us. That also means if the remote had other changes that weren't conflicted, what is it gonna do?
Still pulling in.
It's gonna pull in everything on ours. So, just things to remember. Choosing ours, you're choosing this experience versus that experience. So just remember that. It's the full deal here. So sometimes that's why you wanna kinda go through hand by hand, select what you want. There we go. Pretty straightforward. We checked out ours. Now all we have to do is just simply merge it. So I'll just simply go get add this, get commit. Let's see, merged. Why not? And these commit messages are just getting worse as the day goes on, which really represents true using Git. This might be the most true version of using Git, is where your commit messages just disproportionately get worse as time goes on. It's just the worst, right? All right. So we can do a quick little log. I can go get log one line graph, and we'll just do like the last 10 commits. And you can see right here, you can see the a+7 over here, but then we just merged in a8 with a+7, we get the merge. So there we go. I mean, I always go back and forth in some sense of whether I do like rebase or whether I do like merge. Like in some sense, I do like this piece of history right here, which is I get to see that these two things happened and we did make a proper change to the code in such a way, and this is the result of the conflict. I do like that experience. I think it is a little bit more sensible for me to understand how a bug could form, because if you have a conflict and you use rebase, it kind of erases the idea that you even had a conflict, and it just looks like linear history. It's kind of like a you choose your own adventure. I always go back and forth. I don't feel like I can convince myself either way to love either one, right? It's for whatever reason, I don't seem to have a solid, like, this is the only way to do it here. It's just like, you convinced me. Tomorrow I'll be all about rebase. Today I might be all about merge for conflicts. It's the life I live, as an engineer. It's just, it depends, just continuously and ad infinitum for all of the rest of my life. Anyways, good reminder, if you don't want to mix merge and rebase, start getting these like commit merges, and they start getting, it's very hard to keep your tree kind of straight, so you really do want to try to stick with one strategy and at least make sure they're in sync, and then you can kind of diverge once they're in sync, but I tend to try to never mix them both, because then you just start getting merge commits constantly, and just nothing feels good, it's just trouble after that. So let's merge everything up and make sure that our hello git and remote git are in the exact same position, and then we'll start doing the next part. Okay, so git push origin. I don't know why I'm saying the whole thing here. Again, got owned again. Get checkout bar. Go back, push it up, go back, get checkout trunk, so I don't goof that up. All right, we're in. By the way, if you guys are wondering, how in the world am I switching between projects so dang fast? This is called TMUX. I have an entire course on Front-End Masters all about how to use your system well. Includes Vim and all the good stuff. If you don't use Vim, that's okay. Vim's awesome. It makes me entertained. I know most people don't like it, but hey, I think it's great. All right, so we're gonna do the exact same thing again. We're gonna create another conflict with this a+9, a+n add, #add, by the way. Forgot to say that. There we go. SEC rules now. Wait, FEC? Which one is it? One of the FCC? Anyways, one of the governmental agencies, you have to say add after things. I don't know. Anyways, all right, so let's do a+9 and hello. Let's do a+10 and remote. Don't laugh at me. And do those two, and then then let's do a rebase, and then let's try to select ours. Let's just really drive home the point that ours is theirs and theirs is ours. Even though we should already be there, but let's just do it anyways. So I'll go back to hello. I'll open up README, set it to 9. Git add this. Oh, there's no file name that. Git commit. a+9. Switch over here. Then README. 10. Awesome. Okay. So now if I git pull rebase, we have the conflict. Git check out ours. Remember, we're doing ours here on purpose. If we do that, and then we cat out README, you'll see right here, we selected hello get. We did not select ours because we selected ours, which is not ours. Okay, good. Good. I just want to really make sure. We really are fully on the same page here. So it's just such a goofy part. So there we go. So that means if you're going to do this, we need to select theirs.
But this is...
So I believe I do a little change right here.
But this is... If you want to, for example, is... Okay.
Awesome. Okay. So now if I get a pull
This you want to
rebase,
exactly.
we have the conflict, get check out.
Get check out hours.
Hours. Remember, we're doing hours here on purpose. If we do that, and then we cat out readme, you'll see right here, we selected hello get. We did not select ours because we selected ours, which is not ours. Okay, good. Good. I just want to really make sure. We really are fully on the same page here. So it's just such a goofy part. So there we go. So that means if you're going to do this, which is not ours.
Exactly.
Okay, good. Good. I just want to really
make
sure. We really are fully on the same page here. So it's just such a goofy part. So
exactly. Ours is theirs, and theirs and ours. Rebase from upstream and resolve the conflict with ours.
there we go. So that means if you're going to do this, we need to select theirs. So I believe I do a little change right here. We do this whole ours is theirs business. Okay, so let's just check out and use theirs instead of ours. So I'll go get check out theirs readme. There we go. So now when I cat that one out, you'll see it's our change. Awesome. Get added, get rebase, continue.
That's
Fantastic. We've now done it. We've selected ours, and we have our change in.
But again, this is you want to run this command for that.
I know this may be shocking. There's actually more with Rebase. We can continue to rebase forever. So this one won't be as long of a part. It's not nearly as confusing, but we're still rebasing, okay? You can do a lot with Rebase, but I really have only ever used it to squash commits. I don't use it to like edit commit messages or to drop commits. I don't think I've ever dropped a commit in my lifetime. It's an option. It's, you just put D in there and it just drops it, but I've never actually done it. So, you know, there's a lot of options. You just don't have to use them all. I always use it for squashing everything. And so let's set up the repo with 3 just quick sample commits in the remote Git at the end of the README and just say like added 1 to the end of the line or something along that line. Whatever you want to, however you want to do, just 3 quick, one after another at the end. So I'm just going to go echo 1 to the end of README, get add this, get commit 1 to the end, and then do it with 2. I can find myself wanting to write like a little bash script to do it for me, but it's like so small, but at the same time, it just feels so right to automate this. 3. Do you guys ever have some sort of automation paralysis? Or instead of doing the thing, like that was 3 small commits. I'm like, I gotta write a bash script for this. I can't be spending time writing the same thing 3 times. It's ridiculous. Automation paralysis, real thing. All right, so there we go. So if I go get log, 1 line 4, you can see 1, 2, 3, then our A plus 10. Okay, cool. We have these 3 new commits here. And now what we're going to do is we are going to use Rebase Interactive. So how Rebase Interactive works is that you do a get rebase, you do an I, and then you add a commitish. A commitish is a commit or something like a commit. So head tilde some number starts at your head and walks back a commit however big that number is. So if I go head tilde 1, that's 1 commit back from head. If I do head tilde 3, that's 3 commits back from head. So
not being glib, this is a genuine question. Commitish, is that a private term? Is that a term that like you'll find in the man pages?
I'm pretty sure you'll find it. I'm pretty sure I'm not making this up. I'm pretty sure. What are commitish and treeish in Git? There you go. So I thought it's a good thing to know. A commitish. There's a dash in it. I didn't put a dash in there. So, but it's a fair question. I do say things in a rather abstract way sometimes. This is just not one of them. All right. I should have put a little dash right there though. All right. So let's do an interactive rebase with these 3 commits, and let's use the head. By the way, it does make sense. It's not a word. It does make sense, though. And I like it. All right, so we're going to squash 3 commits. So do get rebase dash I, and then head tilde 3. You want to squash 3 commits. So get rebase dash I, head tilde 3. And this makes sense because what you're doing is that you're going back 3 commits, which is actually not, it's the 1 commit before these 3, is 3 commits back. We're going to go there, and then it's going to replay these 3 commits on top, but we get the chance to say, how do you replay it? So this makes perfect sense with how Rebase works. We're just now able to say what to do. And it comes with a really nice little comment right here to kind of tell you what you should do. So as you can see, like right here, squash, S for squash, and the commit will be melded into the previous. So if I go right here and go S, 2 and 1 become 1 commit. And so get melded into the previous. If I do an S right here, it'll be now 2 and 3, and 1 and 2 all become 1 commit. And so this is like the interactive side. You get to choose how it replays. And so I'm going to choose these things, and then I'm going to save. When it does that, it gives you the option. It puts all the commit messages into a single file for you and gives you the option to like change it however you wish. So I'm just gonna go here, do that, and I can say 1 through 3 to the end. Why not? There we go. So now if I go git log, I'll do the one line form. You'll see right here, 1, 2, 3 to the end. I've taken all 3 commits and turned it into one commit. Yeah. So this is that whole history editing thing people talk about. And if you do this and you push it to a remote and then you do it again and try to push, it's going to say, no, you can't do that. You've just changed histories. That's when you use force to say, no, I know best. I make history. And some about Rage Against the Machine, who controls the past now, and then boom, you're off and running. My general workflow, by the way, I've already talked about it. Do squash me messages, a bunch of little small commits, turn it into one commit, push it up there. And then inevitably, like every other human on Earth, I push up my commit, I add the people that are going to review my commit, then I look at my commit on stash and go, man, that was such a stupid commit. I can't believe I just put people on this. And then I have to go through really quickly and try to make some changes, but then I want it still to be one commit. So then I'm like squashing and commit amending and force pushing. It's a very embarrassing cycle one has to go through.
Wait a single moment.
Let's take this repo, and you're never going to guess what we're going to do. I know this may be stash, and go, man, that was such a stupid commit. I can't believe I just put people on this, and then I have to go through really quickly and try to make some changes, but then I want it still to be one commit, so then I'm like squashing and commit amending and force pushing. It's a very embarrassing cycle one has to go through. Let's take this repo, and you're never going to guess what we're going to do. We are going to clone, but we're going to bisect as well. You would never have guessed that, would you? All right, so if you don't have the course open, it's just github.com/theprimogen/git-bisect. So you can go to GitHub and go grab that. So we're here. Now, we kind of have a classic problem. This happens about once, twice, a few times a year where you have to do this, where there's a whole bunch of commits, and something has gone wrong. You don't know when it's gone wrong. You just know a while back it's good, and currently it's bad. And you want to find out exactly when did something go wrong. And so this is called git bisect. It's not a common problem, but I definitely run into it. And the longer your testing cycle is, the more you should know that this exists. Because if it takes you 1 second, I'm sure there's a bunch of people that are just walking back 10 commits at a time. They don't even know git bisect exists. So therefore they're just like, it's not, I don't have to care. But if you have like a 10-minute testing cycle, all of a sudden you want to be as efficient as possible, right? So, but there's a lot of different ways we could do this. One cool thing is with logs, you can actually search through logs. And this is kind of a neat technique in the sense that if you just want to find a change around a particular component, and everyone does a pretty decent job at putting in good logs, you could find a change around that particular component, even if it's spread across a couple different files. Maybe there's, so that way you're not just looking at a specific file, but maybe you're just looking for a usage of a specific item throughout the code base over time. And so you can grab all those things. Obviously, some of the cons of using logs is that sometimes you don't know a keyword to search for, right? Like there's a bug, but you have no way you could really look through the logs to know why or where that bug change could be. Commit messages aren't always the best. I know we all say we're going to do better. Like our good commit messages starts tomorrow, and then it just doesn't happen. Sometimes you can't boil it down to any specific word, or there's just too many commits to the file. Like, right, there could be hundreds of them, so you're like, okay, I can't just like do a quick check and grab it. One reason why I tend to like just do a quick log look is, let's say it takes 2 minutes to test to see if it's good or bad, and I know like the file that it's probably in. I could do a quick log search. Oh, look at that. There's one change here. I'll just test this one change, and if that one, is the problem, I'm like, got it, right? Like you can just kind of look at the change and go, okay, this is pretty simple. I can see exactly why. So it can be pretty fast. So you can actually search. You can search with logs with grep. But before we do that, we gotta do this little npmi thing, right? This is a node thing, okay? So do a little npmi. It might take. What are you making fun of me for using npm?
No, I have to install npm. I don't have a node on here.
I take. What are you making fun of me for using npm?
No, I have to install npm. I don't have a node on here.
That was amazing. If you didn't hear, there's someone here without node. How great is that? Based. You are now the new coolest. Do you want to come up here and be? You want to?
So badly.
You don't have to participate if you don't want to. It's pretty easy. It's a step by step. You me. All right. Now that we did that, all right. So next, try to run a test. npm run test. I actually did node specifically because I figured there's no way people aren't gonna have node on their computer. Man, I can't believe this actually happened. This is so great. Okay, npm run test. I didn't want to be like, you don't have cargo? Well, let me tell you about Rust. Like I don't want to be that guy. So, yet here I am telling you about node. So I intentionally just put like a sleep in here, so you have to wait 30 seconds to see if it fails or not, right? Like this is real life, right? This is what happens in real code bases. It takes a lot longer to figure out if something is broken or not broken. So you really don't want to have to live this life constantly, right? Right. Thank you for agreeing. I do appreciate that.
Exactly.
All right, there we go. One failed test. Expected 138, but we received 140. Dang. That stinks, right? You can actually see it right there. See? I told you, I'm literally just sleeping right there. All right. Fantastic. We got that all done. Observation, we know that the foo function is failing and the test foo are failing, right? So we know that something's wrong with the function called foo. So what we can do is we can use, by the way, I say you can do man get log and search through logs. If you don't know, in oldie computer speak, searching is called grep. These modern Zoomers these days just use the term search and they don't even know about grep. Grep is fantastic. So if I told you to go if I told you to go in here and find search, you just wouldn't really find the thing because it may contain the word search, but none of them actually are grep. So you got to use grep, right? And there you go. So you can do a grep with a pattern. And so this is from the log. You just simply get to look through any of the commit messages with the word foo in it. So that's like a strategy we can do. So I can go get log grep foo. And so look at this. This is not about foo. This is not about foo. Like, it's kind of hard to search.
So it's now looking
so I
at
can go get log
grep
foo. And so look at this. This is not about foo. This is not about foo. Like, it's kind of hard to search. I mean, this one sounds pretty suspicious. Altering food for new specifications, right? That sounds pretty good. What you can also do is you can actually use -p. -p also puts the changes in here. So then you can go, okay, well, what are all the changes? And as I search through, this looks pretty suspect, right? So learning a thing or two about searching the logs can be very, very useful because sometimes you can stumble upon things or you can look at changes over time for a specific item, and it's kind of nice being able to use. So there we go. So grep, that's what we're using. And so we were able to easily find the problem right here just by looking at it. Obviously, we know the problem right. It's a very trivial problem. We're 2 off, and look at this. I don't know. We times by 2, and this one's, that one exactly fits the need. So we got lucky on that one. The problem with this is also like a lucky search. So if you're looking to solve a bug, definitely this one errs on the side of luck to be able to get like a good term with a simple set of changes that you can just look at, and it's like, oh, there it is. So I often don't use this, but every now and then I'm like, ooh, there was this change I did a while back, and I want to be able to just go straight to that change and go look at, and so I can kind of know in my head where or how I'm doing something.
It's like you just like mapping.
I like searching. Okay, number 2, you can also search by file. So we already know that it's in the problem is in the index file, I think it is. There's only one file in here. Yeah, there's only one file. Okay, so you can go get log, and we'll do a little p, and then we can go source index dot, is it JS or TS? What are we at? Oh yeah. And then you have to do a little dash. You're gonna only search in the log for with these specific files, and this will actually get you the change set only for these files. That's it. So there's only been 2 changes in this file, and so this is a nice way to be able to reduce down the change you're looking for to a file. You can pass in multiple files. Very, very useful. You can mix and match. Grep.
That is actually
it's
powerful.
Good to have this power with you.
This is actually
powerful,
bro.
Change itself. So there's a lot of cool opportunities here with log.
That's a little.
Just
That's
it
powerful.
does exist.
Git log here help you to actually walk back through the history of that particular file.
Honestly, log searching tends to be a drag. Often doesn't work. If I could spend 1 minute looking at the logs to find a bug that could take me 2 hours to find, of course I'll always make that trade-off. Wild shot in the dark. But most of the time you have to do this. Git bisect. Bisect works by searching through Git's commits for you, and you get to mark if something's good or bad. However you decide, it's good and bad, and then it will do the legwork to determine which commit you should look at. So it's pretty clever. There's some unique properties that make this true. All commits are ordered. I've been saying this. I intentionally said this. That the order of commits is effectively time, which means that if I go back 1 commit, that commit should be further back in time, and so you can kind of see how that would work. That means if I go halfway back, I've gone halfway through effectively our project's life cycle of some sort, however, if they're evenly spaced out. So everything is in order, which means it kind of acts like an ordered array, correct? In some sense, yeah, it's like an ordered array. Another thing that you need to have for bisect is that you need to know the 2 changes. It doesn't matter how far apart they are. Let's just say you know that it's currently broken, so you go back 1,000 commits and it's working. That's fine. You just need a point in time in which there's 2 changes. That's it. So let's talk about property 1, because I think it's really interesting. If it currently fails and you go back 10 commits, and it's still failing, what can you say about the going back 9 commits? Is it going to pass or fail?
You're going to fail.
How about 8 commits? Fail. 7 commits, fail. 6, 5, 4, 3, 2, 1. All of them are going to fail, right? Like that's the idea of git bisect, is that due to time and assuming that the bug isn't some weird Heisenbug floating in and out of space, you should be able to quickly go to the correct solution. So to kind of put it visually, if you had commit A and commit B and you have no idea where it's failing at, if you pick the middle commit C and you test it, if C works, what can you say about this graph?
That anything that is before C will work.
C. Whatever followed it.
C and B, right? You've cut the space in half where the problem could be, right? Yeah. And again, if C fails, what can we say? Well, we can say that between C and B, it's bad, and between C and A, the exact opposite.
But again, exactly, this is the exact opposite.
C. Whatever fault it.
C and B, right? You've cut the space in half where the problem could be, right? Yay! Or yeah, the problem lies by to say it inverted. A through C is good, and this other side is unknown. And so the exact opposite's true. Given the exact same situation again, if C fails, what can we say? Well, we can say that between C and B, it's bad. And between C and A, we just don't know yet. So we don't know if it's good or bad. We just know it's bad at C, so it's bad up to bad all the way up to B. So that means we can select we can cut half the space every single search. And this is the fundamental for binary search. This is if you think about a binary tree, walking a binary tree, it's the exact same kind of principle in general. This we're just doing it with commits instead.
Does using bisect make an argument against rebase since it needs to be in order?
No. Rebase, I mean, it's it with commits instead.
Does using bisect make an argument against rebase since it needs to be in order?
No.
No.
Rebase, I mean, it's about your history of your branch. I mean, you've moved your stuff forward, but at some point it's committed and it's in the branch, or it's in. So yeah, if you move your stuff forward and you test it and it's still broken, then it's broken until you find the working commit. It doesn't really change anything. All right. By the way, I don't know if you know this, but Front-End Masters has a free algorithm course. I heard the guy that teaches it. It's pretty cool. That's what I've been told. Kind of sounds like Gilbert Godfrey though, or Charlie Day. Wish Charlie Day. Yeah, that's another one that someone said to me, and it really hurt my feelings. Anyways, it's full for told. Kind of sounds like Gilbert Godfrey though, or
Charlie Day.
or Charlie Day. Wish Charlie Day. Yeah, that's another one that someone said to me, and it really hurt my feelings. Anyways, it's full free. Hashtag ad, everybody. Hashtag ad. Okay, so some pros. You don't need to know anything about the bug. You don't need to rely on commit messages. You don't need to rely on anything other than a way to test to see if it is working or not working. It's the fastest way to search a sorted space is via cutting the space in half every single time. There's not a faster way, unless if you have some sort of hash map in which you know where the good and bad are, like unless it's hash mapping. You don't have to search only for a bug. Say there's a performance regression. Say there's a performance improvement. Say there's anything and you want to find it happening. If you have a test that you can prove that it doesn't happen, you can bisect your way to the commit that changed whatever. So it's a way to do change detection more than anything else. The only con is that if it takes a lot of time to test, and you could do some alternative means to find the change, maybe a quick log search would be your best friend, just to like give a shot in the dark as opposed to having to deal with bisect for hours if it takes a long time. Anyways, so you get the idea. So when you cut space in half, it's log of n. So it takes 7 searches to go through 128 commits, 1 search to go through 1 commit, right? So it doesn't grow very fast at all. It grows logarithmically. It's very fantastic. All right, so the basics of bisect, all you do is you say get bisect start. Then you say get bisect bad, saying, hey, the current commit's bad. Then you select a good commit. And then at that point you test and you just tell it whether it's good or bad. You know, just start checking out stuff until it gets to the exact point in which it found the error. So you just keep on doing this over and over again until it stops. So we're gonna do the exact same thing. We're gonna take the first commit of the repo and the current tip of master, and we're gonna try to find where does it break. So get bisect start, step 1. Then get bisect bad. So I'm saying this commit is the bad commit. Now we need to get the very first commit of the repo. There's like a lot of different ways to do it. So I'll just go like this, get log, 1 line. This is just very, very easy. There it is, right there. So I'll just copy this one out, the B56 ED57. Then I can go get bisect good right there. So I'm going to search the entire repo from beginning to end. There we go. It says bisecting 11 revisions, roughly 4 steps. So is this one good or bad? I'll go like this, npm run test.
I wanted to say binary search so much when you're talking about that. I was just like, it's right there.
It's right there. All right, look at that. It failed. Okay. By the way, npm run, it doesn't run it once. It just keeps it on watch mode because by test default apparently is watch. So that means we need to go get bisect bad. And there it goes. There's 5 revisions left. Roughly 3 steps. Oh, look at that. This one passed. Fantastic. So I'll say get bisect good. All right. 2 revisions left, roughly 2 steps. Let's run test. All right, look at that. It passed. So we'll do a little get bisect good. And now there are 0 revisions left. This is the last step. I'll run it once more, and now either the commit I'm on is the good one or the bad one. And so it's able to tell if it's good, that means the next commit over is the bad one, the offending commit, the bad change, or this is the offending change. And so we'll be able to tell with this last test. I refuse to git rebase this. I refuse. We will experience the weight together. All right, so this one failed, so I just gotta go like this. Git bisect bad. And Porque Maria. Bro, right there. It says it right here. It says apparently 0 bad. And Porque Maria. Bro, right there. It says it right here. It says apparently 0 steps left, which is a little suspicious. Okay, well we gotta run the test once more apparently. I'm not exactly sure why this one went this way. In all the times I did it, it actually was done after 4 of them. But I guess we're gonna wait. One last 30 seconds. Porque 972FA2A. Well, look at that. Git bisect bad. So it tells you right here. This one is where it went wrong, and this is the commit, in fact, which went wrong. So it's able to go through, and we're able to kind of find where the problem was. But here's the deal: was that kind of annoying? Was that like not a fun experience? I'm gonna scroll all the way through this. You know, you can automate it. So let's do it again, but this time let's add the word run to it. Okay, so I'm gonna go here, and I'm gonna go. Let's see, get status, get a bisect reset. We're back at the we're back at the tip. So now we just gotta go like this: get a bisect start, get bisect bad, and get bisect good right here. Then go get bisect run, and then I think it's what is it? It's node modules bin by test run. If you do dash run, it doesn't try to watch. Therefore, it'll just quit, right?
So you need to go to the binary here.
And now all we have to do is just wait. Just a little bit of waiting. By the way, I see some people saying they didn't know that this existed. This is why it's really good to always just do a quick little run through of the friendly manual or a couple git searches and just kind of know how the things work or how people use it, because often you'll find that you're doing something fairly inefficient when the better thing is just right around the corner. Look at this. Hey, look at that. It found the commit. Look at that. We didn't even do anything. Found the commit right here. How nice is that? So bisect run is like really nice. You should definitely use bisect run if you have a problem, especially if it can be boiled down to a quick test to run.
Exactly.
Beautiful, right?
But if this can be, if this can be boiled down to a run test.
All right. So sometimes we have a decision we have to face as programmers, which is to push forward or to roll back. I think we've all been there. Sometimes you got to revert, right? You made a change. It was a failure. Nobody's happy about it. Nobody likes you. And now you need to revert it. So, by the way, if you're confused about the difference between revert and restore, just go read about restore. Restore effectively just changes any change into what the previous state was, whereas revert is actually making, like revert is effectively like the antimatter to matter. It is going to make an inverted change as a commit. And then you commit that. So it actually changes what you've done invertedly. We'll see in just a moment. It's very fantastic. I'm not sure how else to describe it other than it did what you did but backwards, right? All right, so let's look at it. So reverting is simple. You just need to provide a commitish, right? So I just need to revert something, and then it will work. All right, so let's go to hello git, and let's revert the commit with log message e. Before removing it, check the contents of the commit via log with -p. So, does anyone remember how to search the friendly logs?
Yeah, reflux.
-grep. That's right. Great job, everybody. I can't believe you guys all said that out loud. So I'm going to go to hello.
No, if you want, with log, the friendly message, one decorate or grep.
-grep. That's right. Great job, everybody. I can't believe you guys all said that out loud. So I'm going to go to hello git, and I'm going to go git log grep e, and then do a little -p to print out the contents. So look at this. Right here, we made this earlier today. We have a little +e right here. Absolutely wonderful. And our commit message was
you want to
well.
Okay.
Awesome. Everyone's happy. I'm happy. You're happy. Dustin is kind of frowning, but most of us are happy here. All right, so now we need to revert this. So I'm actually going to take this, and I'm going to actually take this guy right here, the commit SHA, and I want to be able to take it, and I'm going to use it for reverting. So I'm going to copy the commit SHA, and I'm going to make sure that that's what we're supposed to do at this point, which we're not supposed to do this quite yet. So we're going to go through all this one. Fantastic. You can manually look through it. Now let's revert it. So I'm going to go git revert, and then the hash that you have. So git revert hash. Conflicts is just like, I hate them. And I can never seem to get away from them. I don't know what is wrong with my life. But anyways, here we go. We've conflicted. Oh no. pre-planned. You can get conflicts in reverting, right? Like, isn't that not only are you getting kicked in the shin for the fact that you just made a mess up, you get sometimes conflicted as well. It's just like, this is the worst possible scenario of all time, right? It's emotionally bruising. So we got to do something about this. So what do? Well, we go again, get status. Again, modified both. This looks very, very normal. You'll also notice up here, we do a get revert skip or abort. So let's go to readme. And this one's a little bit more confusing, right? Like, yeah, this is our change, and okay, this is what we gotta do apparently. Like, it somehow has both E and downstream in here when it probably shouldn't have both of them. So what do we gotta do here? Well, let's delete that, right? Delete the conflicts, and then I only want to delete E, right? Because that's what I was trying to remove was E. All right, so I'll save it, and then if we go get status, get add, get status, you'll see right here that we need to now go get revert continue. Awesome. So now it gives us a beautiful commit message. Revert E. This reverts this specific commit. So that way you have this nice log. You can see that this action was intentional. By the way, this is the greatest argument for why you want to rebase squash, because there's no merge commits. There's not all this history that you've just created, and now we need to remove this change. That sucks. Whereas if you have a nice squashed rebase, no merge commit history, removing the change is very, very simple. There's just one step, which is just the change you want to revert. I'm gonna take this. I'm gonna save it, and there we go. Get status. And you'll see we're on a clean thing. Get log one line. You'll see right here, revert E. If we put a little, I say revert, is that even correct? Is it revert or is it revert if you're talking about it in like that kind of sense? I don't even know. It's a great question, me. You can see right here, there's E. We've reverted it. The revert is literally the inverse commit, as you can see. It's not that it removes it from our history, because if it removed it from our history, what would happen? Every branch would now have a invalid state, and everything would be horrible. Yeah. So a revert is when you actually put the antimatter at the front, is how I like to think of it. You just put the opposite commit in front and merge it in. So there we go. We got that opposite commit going. Absolutely fantastic. All right, that's it. Little quick one on revert. You rarely need to use it. That's about it.
But this is when you want to revert a commit because it's put on top of that.
All right, get reset. So this one you've seen me use a couple times because we definitely didn't have any problems earlier, which required me to change history or anything. We didn't have any deviations from this course. It's been first try all day long. But if I did, I would have probably used get reset. There's actually quite a bit you can do with reset. I only use it pretty much one way, which is just get rid of my current changes. That's pretty much what I use. Like, I don't like these, just get the hell out of here, right? Like, that's how I use it. So we're not there right now. We're gonna do a little bit different. We're gonna kind of show you a little bit more. So a soft reset is a reset in which you actually walk back a commit. Your branch will walk back a commit with you, and that commit that you just effectively forgot and changed history will become the change inside the working tree and index. So we just got done reverting E, right? So if I go get reset soft head tilde1, I'm now gonna walk back that commit.
To one, exactly.
It's still trunk, right? We're still in trunk, but if I go get log one line, you'll notice where's the revert? The revert. Where's the revert? It's gone, right? If I go get status, well, look what the VCS drug in, right? Get diff stage, there we go. Awesome, there's the -E. So you can see I just undid the commit. Okay, so that's get reset soft, which means that all the changes now go into your working tree / into your index. So awesome. I actually really like this. It's really great when you say you're teaching a class and you totally mess up. You can actually walk these things back pretty easy, contain all the changes, and know how to work things. I actually really like reset soft. And the best part is I didn't really even know about reset soft for a very long time. Typically what I would do is I would just go into the logs, check out the specific SHA, and then just delete my branch and create that as my new branch. But instead, with reset, a hard or soft, you can just walk it back and you don't have to do that little hopping, recreating, checking out, destroying type thing. There's also kind of like a inverted version of this. Like right now, if I do this reset soft, I can actually commit, right? A new SHA, right? And now I have the same change, but I've changed the message, so it no longer says we reverted E, and it has a new SHA. So I've kind of hid history by accident, right? But I could do the exact same thing in some sense by using git amend. So commit -- amend allows you to take your current changes and retroactively apply them to the commit you're on. And then you can even do amend -- no edit, and that will edit the command that the commit you're just on, but you don't have to change the commit message. And so when I'm doing CI, I literally echo a space to the end of a file, git add, git commit, amend, no edit, git force push. And so that way there's only like one change. Instead of the CI thing where you have like 9,000 changes. So you can do a git reset soft, git commit, and just keep on changing the thing over and over again, or just add a space and do that. So amend, reset soft, fun little move here. I do it all the time. Good times. But remember thing over and over again, or that way there's only like
You can make change and use git commit amend. If you're not familiar with git commit amend, it allows you to meld the current state changes into previous commit and edit the message.
one change. Instead of the CI thing where you have like 9,000 changes. So you can do a git reset soft, git commit, and just keep on changing the thing over and over again, or just add a space and do that. So amend, reset soft, fun little move here. I do it all the time. Good times. But remember, you're always changing history when you're doing those things, so can be a little bit dangerous, All right, so hard. We can do the same thing as soft, except for this one drops the changes to index in your working tree. That means when you go back, it will completely destroy it. So we'll do the exact same thing. We are going to make a little bit of a change, and we're going to destroy our changes with reset hard. So first, make a change to readme, and then add a new file called foo.md. Make those two, and then let's destroy them. So I'll go vim readme, jump in here. There we go, a little bit of a change, and then foo.md. And I don't know, there you go, some Dvorak in there, git status. You can see these two things right here. Now remember, this is a tracked change that's not staged. Because remember, readme is tracked. It's a part of the working tree. Foo is not a part of the working tree. It has never been tracked, it's never been staged, and so we have no information about it. So if I go git reset hard, it will destroy all working tree changes and index changes. So if I go git status, still got foo. I just don't have the readme change anymore. Remember, it just destroys only what git knows about. Now here's the danger. This is like the big danger people fall into. If I go git add this, and so now it knows about this for the first time, and I go git reset hard, it's gone, and there's like no coming back from this one. It's a goner, right? You just erased a file that was never tracked, and so there's no previous history at this point. So, you gotta be a little careful about using reset hard. You can also do the whole walking back. So if I go vim readme and I add a commit one right here and go git add, git commit, a bunch of nonsense, and then go git reset hard head 1, it does the exact same thing that soft did, except for, again, what does it do to the index and working tree? It gets rid of it. So if I go get status, nothing there. It just simply walked me back one commit. So git log 1, you see that I'm at the new shell. So kind of neat. So when you're needing to kind of just save yourself a little bit, knowing about the git reset hard and soft is pretty nice.
It's not really a new shell anymore. The commit message says a new shell, but it's
get out. That's it.
It's not really
the new shell. So kind of neat. So when you're needing to kind of just save yourself a little bit, knowing about the git reset hard and soft is pretty nice.
It's not really a new shell anymore. The commit message says a new shell, but it's
get out. That's it. We are fist fighting. All right, so there you go. Pretty fun times. I don't know. I actually really like. It's absolutely fantastic having these. I can't tell you how many odd times that this actually is useful. That I used to do a bunch of steps to do the same thing. Now it's just like I can just do them in one single command. Because often I find myself like checking out and destroying the past and rechecking out a new branch and doing all this just to walk back a couple commits. And I was like, ooh, I really goofed whatever that was. We should here. Let me revert also the revert. So I'm gonna go like this: git reset hard. There we go. We're back now. We're kind of into this point. Now the revert's gone, so we're just right here. Can you restore git hello to the position it was before we started this section?
With a ref
Is
log.
the SHA the same though, or will be?
With a ref
The
log.
answer? It's reflog. It's always reflog, right? You just got to go find that nice little reflog. Oh, I had a whole bunch of entries here. I did a bunch of extra work. Yeah. You can effectively be able to grab out. Our previous commit was the revert E, remember? We did all that. So we got to go find the revert E. So I can go in here and go get reflog, find wherever revert E is. Ah, there we go. It's right here. And you can do, there's plenty of ways you can do this. I'm sure there's some much more awesome way to do this, but I can get check out that thing. I can get branch delete trunk. I can get checkout dash B trunk. Right? Look at that. I just restored it from doing that. I'm sure there's some fancy, nicer way to do that. I always find myself in habit of just doing that because I'm always, I don't know. Once you do something, then it's really hard to break that habit. And so that's typically how I'll always do it. Even with like reset soft, sometimes I'll just forget that I can do that. And I just do this big hopping thing. It's beautiful. You can do get reset hard. Yeah, you can do a get reset hard, whatever end. Right? Remember, it's a reset hard, and then you can go anywhere. So I can actually reset hard to a branch that's remote or to anything that's a commit. So I could have also done the whole head and then whatever the index was, whatever it was, 14, right? And I could go off and do that. So it's a nice little thing.
Reflog.
All right, stash is not that great, right? We've all used stash. Were we all happy with it? No, you weren't happy with it, okay? You weren't happy at all. You now want to be happy though. So we're gonna be happy by using work trees. So work trees, so the best way to describe them is like a little story, right? You're on a work tree foobar, you're making the greatest progress ever, you're in flow state, everything's going great, but then emergency situation is needed on main, some sort of bug there, so what do you do? Well, typically, we've been doing the whole like git add, throw everything into the stash, switch the branches, make the changes, and then come back, or we could, we could commit it and pull it and try to figure out what's wrong, right? We need to do something, right? Well, what's a little bit nicer is work trees. Let me show you how they work. First off, a work tree, often when we say this phrase, what we mean is a linked working tree. It's not your main tree. The main tree is the one you create when you do a get init or a get clone. Those are the main working trees. A linked working tree is just simply a branch from your main tree in its own state. Remember, every commit can rebuild the entirety of a repo. Very, very important you understand that one point, because this is where it's really used right here. And it's a little bit different because the .get folder is not a folder, it's just a file. So let's do a little bit of this. Okay, first off, you can do a get work tree add to a path. The base name of the path will be used as the branch name. If you don't know what base name is, base name foo bar baz. So this will automatically use your path as a branch name. You can also add in the branch name if you want it, or you can just let it auto do it. Get work tree list will list out your available work trees. If you want to delete it, you can just delete the work tree folder and then call work tree prune, or you can actually do a work tree remove on the folder, and it will do that. So depending on how you want to go about it, it can do either or. The benefits is that it's super cheap to make. Pretty much, like I said, pretty much as cheap as a branch. The real big con with the work tree is if there's high branch setup cost. So like if you npm install everything.js and it takes way too long to do anything, well, that's a problem, right? And so if you have to build like a Rust project and it takes minutes upon minutes, you'll find yourself a little bit more hesitant to use them depending on how long it takes. So we're gonna create a work tree in hello get, and I want you to use foobar as the last item in the path. So it creates the branch foo-bar. My suggestion is just go back one folder from your root of hello get and just use -- or /foo-bar. And when we're done, check out the get folder. So I'm gonna go like this. I'm gonna go get work tree add foo bar. I think it probably already exists. Oh, nice, it doesn't. Let's go.
Okay, get
There we
work
go. We
tree
prepared
add
a new
foo
work
bar.
tree, and it's been checked out at this point right here. So it created a new branch at this current point, which means if I open up foo bar, you'll notice I'm in a repo. I can tell that I'm in a Git repo because I have this nice little thing right here. If I go git log, you can see revert E, A+9, merge. You can see all of our commits in here. We're in the same repo, just on a different branch. Now here's the best part about that. Let's cat out the git log or the git folder. Remember, it's not a folder anymore. It actually just tells you, the file just simply says, hey, I belong here. And so it tells you where the main working tree is. Because this is a linked
This is a
working tree.
copy.
Yeah, I'm gonna do one little quick thing. It's not in the notes, but we'll just do it right here. If I go like this, if I go foo, put in some changes right here, and go get status, and go get add, get commit, put in a little change really quickly. Then I'm gonna go back to hello get. If I go git log foo bar, my change is right there, right? Because it's a linked working tree. It's just another, you just have another entrance into your folder. So that way you can actually, if I go get log status and go get add, get commit, put in a little change really quickly. Then I'm gonna go back to hello get. If I go,
Because it's creating a copy
git log
of that
foo
working
bar,
tree.
my change is right there,
In a
right? Because
linked
it's a
list.
linked working tree. It's just another, you just have another entrance into your folder. So that way you can actually have two running copies, right? So you could actually have your feature development and then just like mainline over here. And so that way you can always, you only have like two folders you're really working on. So anytime you need like update code or do some sort of like emergency switch, you can do that and just leave your working tree in whatever state it's in, and then you never really switch branches. So the idea is that branch switching is almost like an anti-pattern. And instead, you just use work trees constantly to build everything. And that way you never have to undo stashing, just does not exist. You just simply have the file or the branch out as its own folder with its own state, and then when you're done, you just prune it. You just get rid of it. And so that's kind of like the idea, like the ideal idea. But you can also just have like two versions of itself where you switch branches all you want. There's some moves. And so if I go like this, get work tree list, it'll tell me my two work trees. I have my main working tree right here, and then I have this one, which is my linked working tree, foobar. Pretty cool. I like this. I really do like him. Now, remember, there's two ways you can delete them, of course. So that means I can go rmrf foobar. And once I do that, if I go work tree list, you'll see right here, it knows that this thing no longer exists. Now you're probably thinking, how does it know that it no longer exists? It means not only is there a link from your linked working tree to your mainline must also have that information out to the linked working tree. I'm not sure if I know where it is, honestly, just off the top of my head. I think I do. Oh, I bet. Totally pre-planned. Then you can see work trees, right? So you can actually see it right here. So you can see, here it is, that. You can see what head it's supposed to be at. You can see the get dir. So you'll notice that this is no longer a thing. It probably just stats out the file and notices if the file's missing. It just says, hey, this is a prunable work tree. You've already deleted it. And so that's how it effectively is able to understand that I've deleted it outside of Git. So now I can just go get work tree prune. And if I go get work tree list, it's gone, right? Awesome. I mean, I think it's great. I really like it. I love work trees. They're absolutely fantastic. They just solve that one really annoying problem of having to switch things, stash things, commit things early, any of that. All right. All right. Yeah, we can. Yeah, I mean, get work tree remove. We don't need to do that one too. I do love work trees though. They're just my favorite. There is also end files are really painful. So if you have an end file, if it's checked into the repo, which would be a little unusual. If that's the case, then you're fine. But if it's not checked into the repo, then you have like this whole like copying of your end file around node modules. Go's great. It just builds really fast, so that just works out. But everything else kind of tends to be a little bit more of a pain that way. So just something to think about. Or onto named locations in Git history. This is effectively me saying tags, right? I call it a named location because it's not a branch, because a tag is an immutable point in history. Unlike a branch, branches you update, you make commits to, they move all around. A tag is an immutable point in your Git history. And so the best way to think about it is that it has all the setup of a branch, just without changeability. And so how to use tags? Very, very easy. If you've never used tags, simply do git tag, the name of the tag you want to create, git tag delete if you want to delete it, git tag the list amount, git check out a tag name, and you'll check out a tag as if it were a branch, except for you're just checking out a SHA, and so you'll be in a detached head state. So, kind of fun stuff. I go through the various operations here. We'll do this one right here. I think this one's really interesting. Tags also show up in the log, so long as you use decorate. If decorate's like your default option, if you create a tag, git tag, foobar, and I go git log, you'll see right here, it also shows up so you know which one you're looking at. So if you're trying to look for a specific version,
so they're using this exactly for looking at specific versions. You can use tag for looking at a specific version for production.
Effectively, you can push tags with git push dash tags. It'll push tags up to an endpoint. There you go. That's pretty much everything about tags. I'm going to largely kind of skip this version because I don't think I've said everything about it. There's not, we kind of know at this point how to use branches. Been using them all day. You understand tags inherently, right? Any questions on tags? No, they're pretty straightforward, right?
Just can't merge them back and forth.
You just can't change them.
Yeah.
That's it. All right. My favorite tool to use is Fugitive. So I was going to give you a little quick look. I use the command line like maybe half the time. The other half the time I use Fugitive. It's pretty dang awesome. So if I go in here, add a new line, this is my unstaged changes, right? I can stage them. I can put them into that. I can unstage them. I can remove them. It's very, very nice to be able to have those kind of fast usages of Git. I think it just makes life a little bit nicer, especially as you get good at it. Let's see. Let's go right here and let's do one more thing, just to make it nice. It allows you to do commit messages right in your editor, which is also fantastic. I like that, and it also allows if there was an upstream to push to. Here, let's go to what's called remote Git. I can also go in here, and I can also push if I want to. So if I press enter now, it's going to go push this up to remote. It's not going to work because we made changes to hello Git. There's problems we have to resync, but I can do that if I want to. I can also jump in here, go into here, and I can CZZ it. It's now stashed. CZA, and it's unstashed. It's kind of nice to be able to do that. It's easy to rebase. If I really wanted to, hit it with the old RI, and it'll do something. I'll have some unstaged. Right, I can go in here. Oh, let's not do that one. There we go, and I can go give it the old RI and go S. There we go. I've now just did an interactive rebase. Just changed it to one commit. So having a good tool to be able to work with Git is worth a whole bunch. So whatever tool you use, I hope, well, first off, Vim's fantastic if you don't use Vim. But if you don't use it and you use that other editor, just learn the tool. I think it's GitLens, right? And if you get really good at it, it can just save a whole bunch of time.
GitLens.
And the thing that really makes this stuff really good it's the reason why I didn't go over diffs really pretty much in this course. I don't think diffs are good to look at on the command line. I don't think they're enjoyable. I don't think anyone here is going to want to resolve a conflict by hand. We all want the ability to, look at the change like this, right? Where you have one side and the other side, and you get to choose which side you want to use. And so I largely don't think that kind of stuff is useful. That's why we didn't go over it. And so please, if you're not using a tool and you're resolving conflicts by hand, learn a tool. It'll make your life like 10 times better, because they can be a real big pain in the ass if you try to do everything by hand.
Especially for this conflict resolution. But it's important to know what's going on behind the scenes.
I'm curious Prime's thoughts on large files / LFS since it isn't covered in the content, and any thoughts on squash merge to keep repos smaller.
Yeah, I don't care about the size. So there's two questions in there, and they're kind of both the same. So Git a large file store is just like it does some efficiency. So the thing that's happening, if you didn't notice, that we could go and restore every commit having every pointer to every file. Now we could restore those files. Those files were compressed and all that. So if you're storing like a 100 megabyte image, it's going to go and it's going to compress this, and then you have to download it. There's like a lot you have to download. So Git large file store just effectively is an optimization for large files, which are just a huge pain in the ass when it comes to Git. And that's why people argue why perforce is better, is actually specifically about large file storage and binary assets. But now with Git, whatever it is, large file store, LFS, it's better. As far as like history size, I don't think you should really care about history size. History's free, right? I just like to have it clean, so when I'm doing a revert, I don't shoot myself in the foot. I really don't want to revert like a six item change with a bunch of merge commits. Like that's what I don't want to do. I just want to be able to just say like revert E, and like that's it. So that's my only argument for why I prefer Rebase over. It's because I inevitably bet against myself. And like that's it. So that's my only argument for why I prefer Rebase over. It's because I inevitably bet against myself.
Outside of just some of the techniques you covered here for your own repo, is there anything that you'd recommend for people who like contribute as far as like working with forks and just contributing to open source in general?
Contributing to open source?
Yeah, like I think the question's more like, is there any techniques here that you use to like, when you're working with your fork and pushing it back, or like, submitting the PR back to some open source repo?
Yeah, I think everything I already stated is exactly it. I try to do one commit, make it really nice. I try never, like, if I can, I try to never make a change ever above about 150 lines. There's some studies that suggest that people will rubber stamp like significantly higher rates if you add more lines. Like there just comes a point where you can no longer review well. So if you can keep things small and do more reviews, it just makes life a lot easier.
It's part of the practice, man. It's part of the practice.
I mean, that's my only real thing is if you're going to be contributing to open source, there's a lot of talk, there's been a lot of angst over open source commits in the last few months. So don't just make dumb commits. That's like a good thing to do. Don't be mean. Remember, it's all free. No one's getting paid out there for open source. Well, I mean, they might be getting paid like $20 a month, but that's not enough to really, be happy with it.
And just to follow up to the ENV question, what's a good way to handle ENV files if you want everyone to have a base template but make their own changes? Do you add it to the repo and then stop tracking
you can add it to the
changes?
repo with like a default one. Save it, then ignore it, so that it's like there, and no further changes can be had. There's strategies, right? You can have that whole like env template or whatever, and env default, and then you just copy it over into yours. But that's all organizational stuff.
Right.
I always do like env dash something. By the way, great plugin. By the way, a great Vim thing. I don't know if you guys know about this, but oh wait, hold on. A Chad stack that was using COBOL. If I go like this, by the way, if you guys don't know, you can get plugins so that if you have your env, it will automatically put little stars right there. If you ever accidentally you never want this thing leaked ever for any reason. It's always good to have this thing on. And so if you're in an env file, they'll just always do that. You can just do a little cloak toggle and boom, right there. Anyways, fun little thing. If you don't have that, I always recommend having that. Cloak, I think it's named Cloak for both VS Code and Vim. Good little plugin to have. I just wanted to mention Vim more if possible, I'd love to talk to you about how your life can improve by using Vim. Is it possible to have a personal git ignore? Someone's asking that. There is. Right before we go, there's actually a file inside of Git that you can do. So if I go like this, here, I'll try to do this really quickly. I'll just go like this. I'll create a file like this. It's some sort of Dvorak file, right? So it's right here. It's this thing right here, git info exclude. So if you add it to the git info exclude, it's a git ignore, but only for you. So if I save this, it's gone, but nobody else gets it. It's one of those like super secret ones, but that's one of them. There you go. This is everything I think you need to know about Git to be useful at your job. Everything else is I don't think you need. Just real facts. There you go. That's it.
All right. Well, that'll be all for the video. Take care. Bye-bye.